Some nights the universe feels like a whisper you can almost hear if you breathe a little slower. In that hush, a question rises like the moon over a dark horizon. Why is everything round? Not just the pearls of water drifting in a space station cabin, but the faces of worlds, the glowing bodies of stars, even the way a galaxy arcs like a luminous river. Roundness shows up again and again, as if nature were telling a single story in many dialects. If you follow that story back to its first sentences, you find two old characters on every page: gravity and spin one hand that gathers one hand that stirs. Picture a nursery of planets before any planet exists. A great cold cloud of dust and gas circling a young star grain so fine they float like breath. At first there is only scatter-powdered rock ice crystals, molecules nudged by starlight. Then the faintest preference begins. Gravity is patient. It doesn't shove, it invites. Grain meets grain. Static kisses dust into clumps. Clumps meet clumps. 1,000 tiny taps become a soft drumbeat of collisions. The cloud thickens. Light from the central star turns to gauze as it sifts through eddies of matter. You could hold out your hand in this place and catch centuries. All the while, motion refuses to sit still. The cloud spins because the larger nebula once spun. The cosmos keeps receipts in the language of angular momentum. As the material pulls inward, it must spin faster, like a skater drawing in their arms, like a storm tightening its eye. Gravity prefers symmetry. Spin prefers expansion at the waist. Between those two preferences, shapes are negotiated. That negotiation is the quiet reason droplets bead planets, smooth stars breathe evenly behind their blazing masks. Gravity pulls equally from every direction. Spin tugs most strongly along the equator. The sphere is gravity's vote. The bulge is motion's amendment. Round almost. So, before we continue, hit like and subscribe so you don't miss a single revelation as this story unfolds moment by moment in real time. Tell me in the comments where you're watching from, what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You are the reason we can keep following the impossible, and for that, thank you. Hold a droplet in sunlight. Even on Earth, where air presses and wind frets, the droplet tries for a curve. Up on the International Space Station, freed from weight, water shows its true desire. At once, it gathers into a perfect pearl. Their surface tension plays the role gravity plays for planets, a small-scale echo of the same rule. The surface of a sphere is the minimum skin for the volume it holds. Less skin means less energy, fewer places for imbalance to hide. In a universe that corrects what is uneven, roundness is a promise kept. But the promise is never signed in silence. Imagine that planet nursery again. As the cloud collapses, points that are slightly denser pull in more material, and embryo worlds are seeded. They grow warm from compression, glimmering like coals inside the fog. Every piece wants the center, because gravity has no favorites, no corners, no directions. It simply shortens distance between things. The result is a shape with no privileged edge, a shape where every surface point stands the same distance from the heart. You can call it elegant, but it's really inevitable. If a body is massive enough that its own weight defeats the stiffness of rock or ice, it will sag toward a sphere. Mountains slump over geologic time. Basins lift. Imperfections relax like fabric after a day's wear. Worlds become themselves. Spin, restless twin that it is, writes its own signature across the finished face. Earth completes a rotation in just under 24 hours, and that turning pulls the equator outward by a gentle hand you never feel. We live on an oblate spheroid, a word that sounds complicated to hide a simple truth. The poles are slightly closer together than the equator is wide. Jupiter spins in 10 hours and bulges more boldly. Saturn, made mostly of light gases, is squashed enough that your eye can tell. The message is the same from raindrop to ringed giant gravity sculpts, spin edits. If you step inside a star, don't worry, we'll go with imagination, not heat shields. You'd find the same conversation continuing behind curtains of fire. Gravity pushes in, fusion pushes out. The two hands meet and hold layer by layer in what astronomers call hydrostatic balance. Here round is not decoration. It is the geometry of an agreement, the smooth face of truce. Even the sun, roiled with loops of magnetism and seas of boiling plasma, is astonishingly symmetric. So round that a finger laid on a globe could measure its imperfection. When the truce breaks, the story changes, a massive star dies, its core implodes, and gravity wins so completely, the very notion of surface becomes strange. Even then, the outline the world shows to the outside, what light can circle remains circular. The universe keeps the curve. Walk outside with me for a moment in your mind. Night cool and kind. If the sky is clear, the moon lifts like a silver coin, a lesson you can point to. That curve you see is not an illusion of light. It's the accumulated patience of tides and time. Impacts pocked it, with craters lava smoothed the dark seas, but none of that could break the deeper law. The moon's overall shape is the story gravity kept repeating, while everything else argued and fell asleep. Stand long enough, and you will feel it hum not of sound, but of fit. Roundness is how matter remembers to rest. Why is everything round? Because the cosmos dislikes leftover effort. A sphere encloses the most with the least, most volume, least surface, most togetherness, least strain, because gravity acts the same in every direction, and so the shape that satisfies it best must be the shape that has no preferred direction at all, because spin doesn't overthrow that truth. It only leans on it, creating gentle bulges the way wind lends waves their combed crests without unmaking the sea. Because in the long arithmetic of energy edges are expensive corners of stress, and time is an accountant who never forgets a sum. But beyond the equations there is a feeling, and it belongs here too. The feeling that a round world is kind to the eyes in the same way a slow breath is kind to the body. The feeling that symmetry soothes not because it is perfect, but because it hints at balance at a conversation resolved without anyone raising their voice. Science is our map of that conversation, a way to hear what matter is saying when it falls and turns and settles. It tells us that round is simply what remains when the arguments end. Dust still swirls, light still scatters, in Orion's cold cradles, and in the quiet between galaxies, gravity and spin go on with their ancient work shaping droplets we call planets, and furnaces we call stars, always bending toward forms that waste less and endure more. Tonight, let the mind idle beside them. Let the imagination drift through a protoplanetary disk past the faint sparkle of ice and silicate into the orange-warm hush of a forming core. Feel the inward draw, feel the sideways tug, feel how the two together become a shape you already know, from the curve of a tear, the lantern of the moon, the roundness of your own eye, drinking in the dark. We begin here with a question and a curve, because this is the key that opens every door ahead. If gravity is the patient artist and spin the restless brush, what happens when the canvas itself bends, when space does not just hold shapes but becomes a shape? If a droplet seeks a sphere, what does a black hole seek? If a galaxy flattens, what holds it unseen in a spherical embrace? Stay with me. Slow, steady, grateful. We'll follow the line of this circle into the deeper night and see how far roundness can go. In the beginning, there were no orbits, no planets, no light to cast a shadow. There was only motion, not wild, but measured a whisper of direction written into the newborn universe. Long before Earth cooled, before the sun even had a name, clouds of hydrogen and helium drifted like sleeping giants across the dark. From those clouds came everything we know, and from the moment they began to collapse, two invisible partners stepped onto the stage, gravity and spin. Gravity is the oldest sculptor, quiet, relentless, always drawing inward. It gathers dust gas and time itself, folding chaos into form. Spin is its counterpart, energetic, defiant, always reaching outward. Where gravity clutches, spin releases. Where gravity compresses, spin flings. One breathes in, one breathes out. Their dialogue is the oldest conversation in existence, the balance between stillness and motion, between order and freedom. Imagine one of those ancient nebulae, perhaps 4.6 billion years ago, in the spiral arm of a young Milky Way. It stretches across light years, a billowing continent of gas and dust so vast that a beam of light would take centuries to cross it. Gravity begins to stir within, imperceptible at first, just a deep sigh. Regions slightly denser than their surroundings start to pull more strongly. The whole cloud begins to fold inward. But even as it collapses, it turns. This turning isn't random. It's the memory of something older, a leftover spin from the way matter first formed after the Big Bang. The universe has angular momentum written into its bones. When that great nebula contracts, it cannot lose the rotation it once had. It can only spin faster. Like a skater pulling in their arms, the motion accelerates as the radius shrinks. What began as a gentle drift becomes a whirlpool. Matter flattens into a thin, luminous disk encircling a newborn star. Astronomers call it a protoplanetary disk, but its grace feels more like dance than engineering. Dust grains orbit within it, colliding, sticking, warming in the star's infant light. Each collision adds rhythm to the music of creation. Gravity draws them together. Spin keeps them apart just enough to move to breathe. Between the two worlds are born not in explosions but in slow choreography. This interplay of inward pull and outward stretch repeats across every scale of reality. It's there in the tides breathing against our shores, in the spinning of galaxies in the orbit of atoms around their invisible hearts, even in our lungs. When you inhale, you draw the world inward gravity's act. When you exhale, you release spin's echo. Yin and yang inhale and exhale, the same symmetry whispered in different languages. In the quiet of space, gravity and spin are not enemies. They are partners that keep one another honest. Without spin, gravity would collapse everything into singular stillness. Without gravity, spin would scatter creation into a formless storm. Together they find compromise, a shape that neither destroys nor dissolves. The circle, the orbit, the dance. From a distance, a protoplanetary disk looks serene, a ring of light floating in emptiness. But within it is a storm. Particles collide at tens of thousands of kilometers per hour. Friction heats the gas until it glows. Jets of plasma erupt from the poles of the young star, carrying away excess angular momentum, like the sharp exhale of a dancer releasing tension. Even here, the balance must be kept. For every contraction, there must be release. For every draw inward, a sweep outward. This rhythm echoes through myth as much as through mathematics. Ancient cultures sensed the truth long before telescopes proved it. In Chinese philosophy, the cosmos is built on dual motion, the yielding yin and the assertive yang, neither complete without the other. Hindu cosmology calls it the breath of Brahma, the universe expanding and contracting in eternal cycles. In the Western canon, it's the wheel of fortune, the orbit of planets, the divine harmony that Pythagoras heard in numbers. Science has given these intuitions equations, but their soul remains the same. All creation is a rhythm of opposites seeking balance. If you could stand inside one of those young disks, the sight would be both terrifying and holy. The central star burns white gold, its light filtered through spiraling arms of dust. Each grain is a seed of potential, a future mountain, ocean, or moon. The airless silence hums with motion. Invisible lines of magnetic force trace spirals through the gas-guiding currents that twist and arc like cosmic choreography. The whole system breathes an inhale of collapse, an exhale of spin gravity and motion in perfect time. Over millions of years, the dance slows. Dust grains fuse into pebbles, pebbles into boulders, boulders into protoplanets. Their orbits settle into a shared plane, the disk thins and clears. What remains is the beginning of a family, a star surrounded by worlds, each one carrying the memory of that first spin in its orbit. The same law that twirled a cloud into a disk now keeps planets circling in silent precision, never colliding, never escaping. The universe could have been chaos forever, but these two forces, one pulling, one pushing, learned how to dance. Together they discovered the secret of sustainability, that stability is not the absence of motion, but its balance. The symmetry of a sphere, the rhythm of an orbit, the steady pulse of rotation, all of them are the music of that ancient duet. Gravity, the patient hand, spin, the restless brush. Between them, the universe sketches its curves, smooths its edges, and finds the harmony that gives it shape. Every planet, every droplet, every breath we take is part of that same choreography, playing across time so vast we can only feel it as stillness. If you listen carefully to the silence of the night sky, you might hear it, the faint hum of everything that ever was turning in the dark, drawn inward, stretched outward, meeting perfectly in between. That meeting point, that fragile balance, is where worlds are born. Next we'll follow the geometry that holds this dance together, the math that makes roundness inevitable, the proof that balance is not poetry, but law. In physics, beauty often hides behind simplicity. And the simplest rule of all may be this: gravity pulls equally in every direction. That single fact, what scientists call isotropy, is the quiet equation that gives birth to roundness. It is not preference or artistry. It is symmetry written into the bones of space. Wherever gravity acts long enough, it erases direction. Imagine a single grain of dust floating in darkness. Gravity tugs on it from every side with perfect fairness, no bias for up or down, left or right. Multiply that grain by billions upon billions, let them gather for millennia, and the same impartial pull continues. The result is inevitable. Everything squeezes toward the center until the pressure at every point on the surface becomes equal. Mathematically, the shape that satisfies this condition is a sphere, not because the universe loves circles, but because physics has no favorite angle. You can think of it as a law of balance. Any tiny bump on a forming planet experiences slightly more gravitational pull than its surroundings. Over time, the bump is tugged inward, smoothed out. Valleys rise, mountains settle, and matter finds its resting shape a geometry of peace. The universe dislikes gradients. Equal force in all directions means equal distance from the center, and that distance traces a sphere. The same rule plays out from atoms to galaxies. In the language of physics, isotropy means that the equations describing gravity are the same no matter which way you face them. Einstein's field equations, Newton's laws of universal gravitation, they all whisper the same symmetry. Rotate the universe and nothing changes. The melody stays in key. Scientists at NASA's Jet Propulsion Laboratory describe this elegantly. Gravity is isotropic. It acts equally in all directions, and that equality smooths worlds into spheres. On Earth, that equality is not perfect because another rhythm rotation adds its counterpoint. Our planet's 23-hour and 56-minute spin produces a faint centrifugal lift at the equator, pushing outward against gravity's inward pull. The balance is subtle, but measurable. Earth's equatorial diameter is 12,756 kilometers, while its polar diameter is 12,713 kilometers, a difference of about 43 kilometers. The result is an oblate spheroid, not a perfect sphere, but a slightly flattened one. If you could run your hand along Earth's curvature up from the pole down across the equator, you'd feel almost no difference at all. A single step on Mount Everest would alter your height, more than the planet's flattening does. Yet that tiny imperfection carries profound meaning. It shows that the universe is never static, it breathes, spins and adjusts. Even geometry dances. Now look outward to Jupiter, where that same duet of gravity and motion grows louder. Jupiter spins once every 10 hours so fast that its day is shorter than some earthly flights between continents. NASA's Juno mission has mapped the planet's shape with exquisite precision. The data shows Jupiter's equatorial diameter at 142,984 kilometers, but its polar diameter only 133,708 kilometers, a difference of more than 9,000 kilometers. Spin there becomes a sculptor's chisel, carving away symmetry, stretching the planet's middle into a glowing belt. Gravity still wins overall, it keeps the shape smooth, but it must compromise with motion. On Saturn, the compromise is even more dramatic. The planet's low density and rapid rotation produce poles visibly squashed. If Earth were as soft and fast as Saturn, the Arctic Circle would rest hundreds of miles closer to the planet's heart. Yet even this distortion never becomes chaos. Gravity's insistence on equality keeps every atom locked in the same slow conversation: pull inward, stretch outward, find harmony. This harmony is what mathematicians call equilibrium, but you could also call it music. When gravity's pull and rotation's lift find balance, they form something like a chord stable, resonant, complete. Symmetry is the key signature of that cosmic composition. It ensures that the melody of motion never dissolves into noise. The Earth's bulge, Jupiter's whirl, Saturn's flattened poles, each is a variation on the same theme, the universe playing its song in different tempos. To the human eye, symmetry has always carried emotional weight. Sculptors chase it in marble, architects echo it in domes and arches, composers feel it in rhythm. A well-shaped sphere, whether it's a stone polished by river water or a world spinning in sunlight, satisfies something ancient in us. Perhaps because we too are built from isotropy's logic. Our eyes, lungs, even our cells mimic the geometry of equal pull from all sides. When we see a perfect curve, we are seeing the universe remember itself. In laboratories, NASA scientists study this tendency aboard the International Space Station. Release a drop of water into the air and surface tension, a cousin of gravity, tugs every molecule toward the center. The drop rounds instantly a small rehearsal of planetary formation. Photographs of these droplets look uncannily like worlds suspended in miniature, each one a mirror of a larger truth nature left alone always rounds its edges. The mathematics behind this perfection is older than any equation. It's geometry as meditation. In Euclidean space, the sphere minimizes surface area for a given volume, and therefore minimizes energy. Every deviation, a ridge, a corner, a plane requires extra effort to maintain. Gravity is lazy in the most elegant way. It seeks the lowest possible energy state. Over billions of years, that pursuit smooths mountains, pulls asteroids into planets, and gathers stars into glowing orbs. It is a patient sculptor, carving not with tools but with time. Think of it this way. Symmetry is not a decoration of nature, it is its language. The same way a sculptor removes stone until balance appears, gravity removes irregularity until harmony returns. The same way music resolves dissonance into consonance, the universe resolves imbalance into shape. What we call round is simply the moment when every note of force agrees on pitch. The Earth hums quietly in that tune. Its oceans follow the curve, bulging slightly toward the equator under rotation's hand. Its atmosphere rests in layered shells, each one conforming to the planet's gentle oblate shape. Even light, when it bends around a world, obeys the same geometry. We live inside a composition so vast we can't hear its full score, only the local rhythm beneath our feet. When the James Webb Space Telescope peers across galaxies, it sees this language written everywhere: spheres of stars, arcs of gas, ellipses of light stretched by motion. These are not coincidences, but rhymes, gravity's poetry repeated in every stanza of space. So when you next look at the moon, or hold a droplet of rain on your fingertip, remember, what you see is the simplest possible answer to the most complex equation. It is the shape gravity prefers when it stops arguing with itself. Roundness is not an ornament of the cosmos, it is its syntax, the purest grammar of balance. And somewhere in that balance, amid numbers and silence, the universe keeps time with its oldest rhythm. Pull equally, rest quietly, and let symmetry sing. If you could watch a planet being born, you would see an argument that ends in surrender. At first, matter resists, rock holds its shape, ice keeps its edges, gravity tugs and pulls but meets the stiffness of minerals. Yet over time, centuries, millennia, eons, resistance melts. The stones slump, the mountains bow, the crust softens and flows. The world becomes round. This quiet resolution has a name: hydrostatic equilibrium. It's the moment when gravity and internal pressure reach agreement, when every inward pull is matched by an equal push outward. Once that balance is achieved, a body can no longer hold corners or ridges. It settles into symmetry. A world has found its default shape. Hydrostatic equilibrium is one of the most fundamental thresholds in planetary science, a kind of cosmic rite of passage. Below it, a rock can stay jagged forever. Above it, gravity wins and smooths everything into curve. For rocky materials, that tipping point arrives when the object grows to roughly 600 kilometers in diameter. Beyond that size, its own weight becomes stronger than the rigidity of stone. Matter starts to behave not like rock, but like an extraordinarily slow liquid. Over millions of years, it flows until every point on the surface rests at the same distance from the center. What remains is a sphere, the only form that satisfies gravity's patience. You can see the evidence written across the solar system. Take Ceres, the largest body in the asteroid belt between Mars and Jupiter. At 940 kilometers wide, Ceres is big enough to have crossed the threshold. Its gravity pulled it into roundness, turning a heap of rubble into something unmistakably planetary. NASA's Dawn spacecraft photographed its surface cratered, scarred, but beautifully balanced. Even the Great Depression of a Cater crater doesn't break the harmony. From space, the curve remains true. Now drift toward Mars and meet Phobos, one of its two tiny moons. Barely 22 kilometers across Phobos is a misshapen relic, irregular, pitted and lumpy like a fragment of clay pressed between fingers. Its gravity is too weak to smooth its features, too feeble to demand symmetry. You can almost see the debate still raging within it, gravity trying to draw everything inward, rigidity refusing to yield. The difference between Ceres and Phobos is not poetry, but physics mass deciding when shape must surrender. The same law draws lines across every scale of existence. The icy moons of Jupiter Europa, Ganymede, Callisto, are round, each large enough for gravity to mold. The countless smaller chunks orbiting in the rings of Saturn are irregular, still holding the memories of collisions that shaped them. Even the dwarf planet Pluto, at 2377 kilometers wide, is comfortably spherical proof that the law of hydrostatic equilibrium holds even in the farthest, coldest regions of sunlight's reach. The phrase hydrostatic equilibrium sounds dry, but it describes something profoundly tender. It is the universe's way of letting matter rest. When gravity has pulled enough, when pressure has risen enough, there comes a point where every force agrees to pause. Inside a planet's heart, atoms press inward under their own weight until the compression pushes back with equal strength. There, deep in the mantle, tension becomes peace. The world no longer struggles to define itself. It simply is. Human beings noticed this long before we could name it. To the first sky watchers, the roundness of celestial bodies was not just geometry, it was perfection. In ancient Mesopotamia, scribes carved the sun as a circle crossed with rays, a symbol of wholeness and eternity. The Egyptians crowned their gods with discs of gold embodying the completeness of Ra's journey across the sky. In China, the word for heaven was drawn as a circle, earth as a square, an understanding that roundness belonged to the divine symmetry, to the cosmos itself. The philosopher Pythagoras taught that the sphere was the most perfect solid of form without beginning or end. Plato imagined the earth itself as a sphere because perfection demanded it. Even in medieval cathedrals, the domes and halos of saints echo this reverence for curvature. Humanity's oldest instinct was to associate roundness with harmony, continuity, and truth. Somewhere in the geometry of the heavens we sensed balance, and we built our temples to match it. The ancients may not have known about hydrostatic equilibrium, but they felt its consequence every night. The moon's perfect arc, the smooth globe of Venus at dawn, the unbroken circle of the sun, each whispered of a design beyond disorder of forces too steady to see. What those early eyes could not know is that their intuition was exactly right. Roundness is perfection, not by philosophy, but by physics. It's the natural endpoint of struggle, the form everything reaches when energy has no more arguments left to make. Every planet we've ever studied bears the same silent signature. Gravity, the eternal negotiator, presses evenly on all sides. Material strength pushes back until both find stillness. It's a slow, cosmic exhale that may take millions of years, but the result never varies. NASA's Jet Propulsion Laboratory calls it the golden rule of planetary bodies: enough mass, enough time, and everything curves. From Mercury's rocky globe to Neptune's deep blue sphere, from the tiny pearl of Enceladus to the vast storm-wrapped bulge of Jupiter, all obey the same equilibrium. Gravity does not favor beauty, yet beauty appears every time. In that sense, hydrostatic equilibrium is more than a physical state, it's a metaphor for peace. It's what happens when inward pressure and outward strength learn to coexist, when the extremes find balance without destroying each other. We see it in the smoothness of worlds, in the quietness of orbits, in the way planets drift without collision through the dark. Perhaps that's why the ancients saw divinity in circles. They were glimpsing not gods, but the law that gods themselves would obey. The one rule that never breaks the rule of balance. Every round world, every glowing sphere hanging against the night is a promise kept. The universe has done its arithmetic. The forces are equal, the struggle is over, and for a few billion years, until time restarts the argument, the shape of peace will remain what it has always been: a circle drawn by gravity's steady hand. Deep inside Jupiter, the idea of round becomes something almost holy. From space, the planet looks serene, bands of cream and amber wrapped in perfect symmetry, a marble adrift in black velvet. But beneath that calm veneer lies a world that never truly stops moving. A world where gravity is absolute monarch and matter forgets what it once was. Here, roundness isn't a shape, it's a surrender. The deeper you go, the heavier the air becomes. Hydrogen, that simplest of elements, begins to behave like a liquid, then under still greater pressure like metal. It's a transformation so alien it borders on myth. In Jupiter's core, the pressure exceeds 3 million times that of Earth's atmosphere. Temperature rises past 20,000 degrees Celsius. At such extremes, the rules of matter warp. Electrons slip free from atoms, turning gas into a vast shimmering ocean of metallic hydrogen, a fluid that conducts electricity like copper and swirls like a dream. NASA's Juno spacecraft has mapped this inner world indirectly, sensing the magnetic field and gravity anomalies that betray its structure. What it reveals is astonishing. Jupiter may not have a solid core at all, but a fuzzy one, a blurred transition between dense metallic hydrogen and heavier elements dissolved into it. Even definition itself melts under pressure. Imagine standing there, if standing were possible, a descent into pressure so intense that silence has weight. Above you, the clouds roar with winds that never rest, cyclones large enough to swallow continents. Lightning bolts leap hundreds of kilometers, but you would never hear them. The atmosphere is too dense, the sound swallowed before it can travel. Deeper still, rain becomes liquid metal. Droplets of helium fall through hydrogen seas like molten pearls, each drop releasing energy as it sinks. The planet glows faintly from within a slow exhalation of its own birth heat. Every layer curves inward under gravity's hand. Unlike Earth, where mountains resist, here nothing resists. Everything flows. The roundness is total perfect equilibrium between pressure and pull. You could remove the light, strip away the clouds, and Jupiter would remain a sphere to the last atom. Gravity does not permit any other form. The same story repeats across the great gas giants. Saturn, lighter but faster spinning, is so delicately balanced that a stone dropped into its atmosphere could fall for hours before finding resistance. Deeper down, the gas thickens into strange oceans, hydrogen pressing against hydrogen until molecules give up their individuality. The planet's shape, flattened slightly at the poles, is gravity's compromise with motion once again. Uranus and Neptune, far colder, carry mantles of water, ammonia and methane compressed into exotic ices that behave like neither solid nor liquid. Even there, far from the sun, the curve remains pure. Roundness in these extremes is not fragility, but power. It is gravity asserting its rule over chaos. Every droplet, every atom knows where down is the center. No surface, no texture, no peak can defy that pull for long. Planets that grow large enough cease to have edges altogether. They become self-sustaining spheres, oceans of pressure contained only by their own gravity. To understand why, imagine holding a handful of water. Try to make it keep corners, it won't. The molecules slide into the nearest balance, forming a bead. Now scale that to planetary size. The same principle applies, only magnified until it sculpts worlds. Gravity, like water, seeks the smoothest route to rest. The roundness of Jupiter and Saturn is the shape of that rest realized through immensity. In the silence between stars, this symmetry radiates a kind of calm. No edges to break light, no corners to catch shadow. Just smoothness beyond comprehension, storms folding themselves into the eternal contour of a globe. Each planet becomes a meditation in motion, a reminder that even violence can be shaped into grace. The upper atmosphere of Jupiter may rage with winds reaching 400 miles per hour, yet the planet as a whole remains serene. Spin, gravity and pressure negotiate endlessly, yet the outcome is always the same: harmony. If you could watch Jupiter from a quiet orbit for 1,000 years, you'd see its clouds shift, storms drift and die, but the outline would never change. The planet's curve is its mantra recited without sound. Deeper still, the sense of stillness grows. Within the metallic hydrogen core, atoms move so fast and so close that they behave collectively like notes merging into a single sustained tone. The magnetic field generated here reaches millions of kilometers into space, shaping auroras on both poles, rings of light born from pressure and spin. Every photon that escapes those depths is a confession. Even at the edge of physical endurance, balance endures. Perhaps that's why, when telescopes capture these gas giants, their symmetry moves us in ways equations cannot explain. We see not just physics, but patience matter, learning to be still while in constant motion. Gravity pressing inward, spin stretching outward, pressure glowing in between. It is the universe's most ancient meditation: hold everything together by letting nothing resist. Stand back and the scale humbles thought. These planets are not solid sculptures. They are living geometries, rivers of gas coiling into perpetual equilibrium. The roundness we see is not frozen. It's maintained every instant by trillions of invisible negotiations. That's what makes it perfect. In the language of science, we call this stability. In the language of awe, it is serenity. A gas giant's curve is the shape of a sigh, too vast for air, a sphere humming in silence, gravity's hymn made visible. And yet even here, the story isn't finished. For if pressure can turn gas into metal, what happens when gravity becomes strong enough to crush light itself, when roundness collapses beyond its own surface and space begins to curve inward? Beyond Jupiter lies the next threshold, the ultimate surrender, where shape and light and time themselves bow to gravity's will. We are about to meet the universe's most perfect circle, the black hole. At the far end of roundness waits a silence so complete it bends light itself. Here, the curve that once described a planet or a droplet becomes something deeper, a horizon not of color or texture but of gravity made visible. In 2019, the Event Horizon Telescope gave humanity a first glimpse of what that silence looks like. Across the world, telescopes from Hawaii to Chile to the South Pole synchronized their gaze, turning the entire Earth into one vast mirror. When the data was stitched together, an image emerged, a soft circular glow surrounding a hole of perfect blackness. It was not a photograph in the ordinary sense, it was a portrait of geometry. We were looking at the edge of a black hole. That faint ring of fire belonged to M87 Fern, a supermassive black hole in a galaxy 55 million light-years away. 3 years later, the same technique revealed another closer face, Sagittarius A, the sleeping giant at the center of our own Milky Way. Faint radio light traced a circle of astonishing precision, 12 million kilometers across yet perfectly symmetrical. Within that circle, no light escapes, no message returns. The black center is not a surface but an event horizon, the boundary where space itself folds inward, faster than light can flee. For the first time, humanity saw not matter, but the shape of gravity itself, and it was round. If Jupiter's sphere is roundness by pressure, a black hole's is roundness by surrender. Gravity there has won every argument. It has crushed not just mountains or atoms, but the very scaffolding of space and time. Everything that crosses the horizon continues to fall forever, never reaching a floor, only spiraling inward into a place that has no direction left to give. Mathematically, Einstein predicted this a century ago. A sufficiently dense mass curves space-time so steeply that all possible paths point inward. In that geometry, light becomes a captive traveler circling endlessly before fading. The outer ring we see in the telescope images, the glowing halo, is light from nearby gas heated to millions of degrees as it orbits at nearly the speed of light. But the black center, the perfect circle, is the shadow cast by gravity itself. For physicists, it was confirmation of Einstein's equations. For everyone else, it was something harder to describe, the feeling of staring at the universe's own pupil, the place where perception ends. Imagine standing near it, not falling in, just watching. Around you, stars stretch into ribbons of light. Time itself slows. If you tossed a clock toward the center, you'd never see it cross the horizon. Its ticks would lengthen, fade, and freeze, trapped in eternal approach. From your point of view, the clock would hang there forever, perfectly still, on the curve of darkness, while for the clock an entire lifetime would pass in an instant. The equations describe this as gravitational time dilation, but it feels more like mercy, the universe allowing you one last glimpse before silence closes. Inside, all bets are off. Physicists call it the singularity, a point where density becomes infinite, where the known laws dissolve. Yet even that chaos wears a circular mask. The event horizon, the boundary of no return, is always spherical, always symmetrical, no matter how the black hole spins or what it consumes. In a cosmos filled with disorder, this is the ultimate order roundness that no force can break. When the Event Horizon Telescope team unveiled the image of Sagittarius A, scientists wept quietly in the control rooms. Some of them had devoted decades to equations on chalkboards, to data that never showed a face. Now the face was there, orange, trembling, blurred, but unmistakably real. In that circle, the universe showed us its handwriting. It is strange to feel emotion at a shape, but how could we not? Every sphere we've ever known, raindrops, planets. Suns finds its ultimate echo here, in a circle drawn by gravity's absolute authority. What began as a balance between inward pull and outward spin ends here in total inwardness, where even light bows. The shape of peace and the shape of oblivion turn out to be the same, and yet it is not frightening. There's a stillness in that image, a kind of meditation. The black hole does not rage, it simply exists perfectly balanced between being and nothing. Around it matter glows, time stretches, and we tiny observers on a small blue world feel something ancient humility. Because for once we were not seeing an object, we were seeing space itself curved serene and silent. When you close your eyes tonight, remember that circle. It is not just an absence, it is the universe's reminder that even endings obey symmetry. The same gravity that rounds droplets and planets also rounds darkness, completing the cosmic sentence that began with the first swirl of dust. And if you listen closely to the silence between stars, you might hear the echo of that circle Not a sound, but a feeling, the hush of geometry finishing its line. Imagine a whirlpool so vast it swallows not water, but space itself. A place where rotation is no longer motion, through space but motion of space. This is the domain of the Kerr black hole, the spinning kind by far the most common in the universe, including our own Sagittarius A. When a massive star collapses, it rarely does so in perfect stillness. Every star spins, even if slowly, and that spin cannot simply disappear. According to the laws of physics, angular momentum must be conserved, so when the core implodes, it carries that rotation inward, compressing it into an unimaginably small region. The result is a black hole that not only bends space-time inward, but also twists it like water caught in a drain, pulling everything around it into a spiral. This is frame-dragging one of Einstein's most mind-bending predictions of general relativity. Space and time are not static backgrounds, they are elastic fabrics, and a spinning mass drags that fabric around with it. The faster the spin, the greater the twist. Around a Kerr black hole, this effect becomes absolute space itself rotates. To picture it, imagine standing near such a black hole with a grid painted on the void around you, an invisible web of coordinates marking the directions of space. As you watch those grid lines begin to twist, rotating faster and faster, until they blur into a whirl. Light itself is caught in the current, curving into spirals before vanishing past the horizon. You could shine a flashlight straight outward, and its beam would arc back toward the darkness, pulled along by the turning of space-time. NASA scientists describe this region as the ergosphere, a teardrop-shaped shell that surrounds the event horizon. Inside it, nothing can stand still. Even if you tried to hover with engines, blazing space would carry you along, forcing you to rotate with the black hole. The word comes from the Greek ergon, meaning work, because in theory, energy can be extracted from this twisting motion, the famous Penrose process. It's one of the few ways to take power from a black hole without falling in. In 2020, NASA's NuSTAR and NISA observatories confirmed that the black hole in galaxy 1H0707495 spins at nearly the speed of light. Its ergosphere blurs so quickly that the region where space itself begins to rotate is only a few kilometers thick, yet within that sliver photons can orbit dozens of times before escaping. Astronomers call these paths photon rings, shimmering echoes of light trapped in gravity's whirl. The Kerr solution to Einstein's equations describes all of this with eerie precision. Where the simpler Schwarzschild black hole is a perfect sphere of stillness, the Kerr black hole adds rotation, flattening the event horizon into an oblate shape, much like Earth's equatorial bulge, but on a scale where the laws of physics bend. The inner region splits into two horizons, an outer one where light is trapped, and an inner one where cause and effect begin to unravel. Between them lies a storm of space-time spiraling endlessly. If the non-rotating black hole is a silent lake, the spinning one is a maelstrom. Light near its poles can escape, shooting out as twin jets that stretch thousands of light-years into space, what we see blazing from quasars and active galactic nuclei. That energy paradoxically comes from order, the rotation of the whole twisting magnetic fields, like ropes, until they snap and release bursts of plasma at near-light speed. Close your eyes and imagine the scene in motion. Around the black hole, gas from a doomed star forms an accretion disk, a luminous whirl glowing millions of degrees hot. The inner edge whips around at half the speed of light friction, turning matter into pure radiation. The colors would blur into a halo of gold and white, then red, as light itself is stretched by gravity. Within the disk, the geometry of space behaves like a liquid vortex, every photon, every atom caught in a graceful terminal spiral. There are no edges, no waves, only smooth curvature. If you could look from above, you'd see light-tracing spirals that tighten endlessly, circling toward an invisible drain where time slows to stillness. The visual is not metaphor but measurement. This is literally how space behaves around a Kerr black hole. It does not merely pull objects inward, it spins the stage beneath them. NASA's Gravity Probe B experiment, launched in 2004, confirmed frame dragging right here near Earth. 4 ultra-precise gyroscopes measured how our planet's rotation gently twists space-time by 0.1 degrees per year, a small but real echo of the same effect that rules the hearts of galaxies. The same law that turns Jupiter's storms also turns the geometry of the cosmos itself. The difference is only scale. On Earth, frame dragging is a whisper. Around a black hole, it becomes a roar. To watch light itself curve and vanish into that whirl is to witness gravity performing art painting in motion, sculpting with silence. The boundary of the ergosphere glows like a cosmic brushstroke, sweeping light into luminous arcs before swallowing it whole. Astronomers describe the scene with mathematics, but poets might call it a slow hurricane made of time. In the end, every photon that escapes carries a message from that maelstrom, that even in the darkest places the universe keeps its rhythm spin curve balance. Space twists light dances and roundness survives not as a shape now but as a motion without end. At the heart of the universe's most violent storms, where space folds time, falters and matter itself is stripped of identity, one thing persists: the circle. Even as chaos reigns, the silhouette of a black hole, the shadow cast by its gravity, is always round. No matter what falls in, no matter how it spins, burns or twists, the outline that remains to the outside world is a perfect calm circle. It's one of the strangest ironies in physics: from disorder emerges the simplest possible shape. When physicists like John Wheeler began describing black holes in the mid-20th century, they noticed something unsettling. Despite the infinite variety of stars that could collapse, some huge, some small, some rich in heavy metals, some poor, all their remnants seemed to look the same from the outside. Their magnetic fields, internal structures and chemical histories vanished as if erased. What remained could be fully described by just three numbers: mass, spin and electric charge. Nothing else. Wheeler summarized it bluntly: black holes have no hair. That phrase, the no-hair theorem, wasn't about aesthetics but about loss. A star can be turbulent, scarred, asymmetrical. Its death can be explosive and unique. But once gravity wins, all the details vanish behind the horizon. Two black holes with the same mass, spin and charge are indistinguishable, even if one formed from a blue giant and the other from a supernova of dust. All individuality, all texture, all history gone. And yet what remains is beautiful. To scientists, this simplicity is both sacred and disturbing. In a universe built on complexity, on galaxies tangled like coral on quantum fields, buzzing with uncertainty, how could the endpoint of everything be so absolute, so clean? Nature rarely allows perfection. It prefers a symmetry, entropy, rough edges. But here the math refuses compromise. Every black hole, no matter how monstrous, obeys the same geometry: a sphere when still, an oblate curve when spinning, its shadow always circular. This persistence of symmetry has been confirmed again and again. When the Event Horizon Telescope revealed the ring of M8070, its near-perfect circularity astonished researchers. The same was true for Sagittarius A. Despite different masses, different environments and chaotic magnetic fields, both showed the same timeless shape. The noise of matter, the tantrums of magnetic storms, all smoothed into a single round edge. Astronomer Heino Falker called it a triumph of simplicity. Others whispered that the universe had just shown us its signature. There's something almost spiritual in that idea. Perfection is unsettling because it's rare. We associate it with control, with order imposed on the uncontrollable. When science encounters it, it feels less like explanation and more like revelation. To a physicist, a perfect circle means equations have reached their purest form, a sign that space-time has no hidden bias. To a poet, it feels like forgiveness, all the mess of existence drawn into one continuous line, unbroken and eternal. Perhaps that's why people wept when they saw the first image of a black hole shadow. Not because it was strange, but because it was familiar. Somewhere deep in the mind, we've always known that everything from drops of water to the orbits of planets leans toward this shape. The circle comforts because it suggests completion. Even destruction becomes serene inside it. If you could drift near the event horizon, you'd see this truth carved in light. No matter how chaotic the surrounding accretion disk, no matter how shredded or turbulent the shadow remains, unflinching a round window into nothing. The disk may flare, the jets may roar, but the darkness keeps its contour. Its geometry at its most stubborn space-time, insisting on balance even at the edge of annihilation. Wheeler's no-hair theorem reminds us that nature hides her complexity behind simplicity, as though the final act of creation is to erase her fingerprints. Inside that smooth circle lies everything that was once intricate, diverse, and full of story. Yet from afar, all we see is harmony, a sphere so pure that it refuses to betray what it contains. For some, that loss of detail feels cruel, individuality crushed, information erased. For others, it's comforting, a reminder that beneath the noise and difference of existence, there may be a deeper unity. The same shape that defines a raindrop defines a star's death. The same law that rounds planets also rounds darkness. Maybe that's why, even in the language of myth, circles have always meant wholeness halos around saints' mandalas, in temples, orbits of heavenly bodies. They promise continuity where endings seem final. The black hole's shadow is the universe's own mandala, a symbol drawn not by hand but by gravity traced in light that can never escape, yet still reveals the outline of the infinite. The physicist stares at it and sees a triumph of mathematics. The poet stares at it and sees eternity. And perhaps both are right. Because in the end, after all the energy is spent, after all forms dissolve, one thing survives a single perfect circle, quiet, absolute, indifferent, yet impossibly humane in its simplicity. For centuries, scientists imagined gravity as silent and invisible tug without a voice. Then in September 2015, the universe whispered, and we heard it. It began as a faint ripple recorded by twin detectors in Louisiana and Washington, part of a project called LIGO, the Laser Interferometer Gravitational Wave Observatory. 2 4-kilometer arms each with laser beams bouncing between mirrors waited for the slightest tremor in space-time itself. On that morning, the beams shifted by less than 1/10,000th the width of a proton. And from that infinitesimal movement an epoch began. The signal lasted just 0.2 of a second. Its shape was unmistakable, a quick rising chirp that climbed in pitch, peaked, and then vanished into silence. Behind that sound was an event 1.3 billion years old, the collision of 2 black holes, each roughly 30 times the mass of our Sun. They had circled each other for eons, spiraling closer as they radiated energy into the cosmos. And when they finally met, their union sent ripples across the fabric of space and time waves of gravity racing outward at the speed of light, carrying with them the signature of creation's most violent embrace. At first glance, the physics is ferocious, 2 invisible spheres colliding matter, compressed beyond imagination velocities approaching light speed. Yet what struck scientists most was not the violence, it was the grace. The final object born from all that fury was perfectly smooth. No jaggedness, no leftover turbulence. From chaos, symmetry emerged. Supercomputers later confirmed what the signal had implied after the merger. Spacetime itself rang like a struck bell. The vibrations faded exponentially, each oscillation shorter and weaker than the last until stillness returned. This stage, called the ringdown, was predicted by Einstein's equations nearly a century earlier. The resulting black hole, having swallowed its partners, relaxed into equilibrium, featureless, spherical, serene. Imagine that for a moment the universe's most cataclysmic event ending not in wreckage, but in peace. In the control rooms at LIGO, scientists sat in stunned silence. Decades of waiting, decades of refinement, and then confirmation that space-time is not static but elastic, alive, musical. Einstein had said as much, but until that morning no one had ever heard the tune. It was as if the cosmos had finally played us a note from its oldest symphony. Since then, LIGO and its European partner Virgo have recorded dozens of such songs, pairs of black holes, neutron stars colliding, even the faint echo of one that may have involved both. Each time the pattern repeats the crescendo, the merger, the ringdown. Each time violence resolves into calm, the circle restores itself. At the heart of those discoveries lies a philosophical truth as old as any myth. After every act of destruction, the universe seeks balance. You can see it in the equations, but you can also feel it in your bones. The same way a bell eventually stops ringing, the same way a storm fades back into still air. Space-time itself seems built to return to symmetry. The circular calm of the final black hole is the cosmos's way of exhaling. And maybe in some quiet way it's also a mirror. Because we too are creatures of imbalance and return. Our lives erupt with collision loss, grief change, and yet somehow we reassemble into something whole. We smooth the jaggedness with time, we settle back towards center. It's the same story at a smaller scale: gravity of emotion, the spin of chaos, the eventual stillness of healing. Physicists describe the ringdown as quasi-normal modes. The term is technical, but there's poetry hidden in it. Quasi-normal means the system is finding its natural tone, again shaking off the asymmetries left by impact. You could almost call it recovery. The final black hole hums, sheds excess energy, and relaxes into the same round perfection that defines all its kin. Think about that, the signature of stability, the circle reasserting itself even in the wake of annihilation. No matter how violent the event, the universe's default answer is symmetry. NASA visualizations of black hole mergers built from LIGO data show this beautifully two spheres spiraling together, their gravitational fields stretching and colliding, sending ripples outward like rings in water. For a moment, space-time itself looks fluid. Then, after the merger, everything calms. The ripples fade, leaving a single smooth horizon unblemished, complete. What began as fury ends as form. What began as noise ends as music. The same force that rounds planets and droplets also rounds catastrophe, restoring geometry to even the most unimaginable extremes. It's a pattern we can almost trust that the universe, despite its violence, loves equilibrium. Perhaps that's why when scientists first played the LIGO chirp converted into sound, it felt oddly emotional. The final note, the ring down fading into silence, sounded like a sigh. The cosmos breathing out after a long-held breath. In that sigh lies the deepest message of all: symmetry is forgiveness. The universe does not stay broken, it reshapes itself. After collapse comes calm, after noise, quiet, order. And in that return to balance we glimpse something achingly human, the will to endure, to heal, to become whole again. The black hole, the wave, the circle, it all tells the same story that even at the edge of physics, beauty survives. From the abyss of the black hole where roundness reigns supreme, we begin to drift outward, far beyond the event horizon, past the glowing accretion ring through curtains of gas and starlight, until the darkness opens into an even greater pattern. At this distance, a strange paradox emerges. If gravity loves spheres, why has the universe painted its grandest structures flat? Why do the Milky Way and Andromeda stretch across space like silver coins, razor thin compared to their vast diameters? The closer we look, the more this contradiction deepens. From raindrops to planets, gravity sculpts roundness as a signature of equilibrium. But step back far enough to see a galaxy, and that perfection changes form. The sphere becomes a disk, the circle stretched spinning like a cosmic whirlpool. The universe seems to have exchanged stillness for motion, perfection for dance. The transition begins with collapse. In the early universe, galaxies were not yet galaxies, only immense clouds of hydrogen and helium, hundreds of thousands of light-years wide, drifting within dark matter halos. They were roughly spherical, at first shapeless and glowing faintly from the newborn starlight within. But even these primeval clouds carried a faint spin, a leftover from the chaos of the Big Bang, and nature, by one of its most reliable laws, never wastes a rotation. According to the principle of conservation of angular momentum, when a rotating object contracts, its rotation speeds up. Just as a skater spins faster, when drawing in their arms, these enormous clouds whirled ever faster as gravity pulled them inward. With every contraction, the centrifugal motion pushed outward at the equator, resisting the inward pull of gravity. The result, the sphere began to flatten, settling into a rotating disk, a galactic embryo. This is how gravity and spin learn to compromise. One pulls inward, demanding unity. The other flings outward, demanding motion. Between them lies the elegant balance that defines a galaxy flatness born from tension. Visualize it like this. Imagine standing far above a newborn galaxy, if such a vantage were possible. At its core, stars form and collapse in a dense glowing bulge, a nearly spherical heart of old suns orbiting the center. But farther out, gravity and spin reach a kind of truce. The gas dust and younger stars begin to orbit along the same plane, drawn into a vast spiral that winds gracefully around the center like the arms of a hurricane. NASA's simulations of galaxy formation show this with breathtaking clarity. Out of turbulent clouds emerge disks so thin that if scaled down to the size of a dinner plate, their thickness would be less than a grain of dust. The Milky Way, for instance, is about 100,000 light-years wide, but only about 1,000 light-years thick, a ratio of 100 to 1. It is, cosmically speaking, a miracle of balance. When the Event Horizon Telescope captured the circular silhouette of Sagittarius AR, humanity saw geometry at its most absolute, the perfect roundness of gravity's triumph. But when we zoom out to see the structure that contains it, the Milky Way, we find that geometry rebelling in the most elegant way possible. Our galaxy's vast disk spins once every 230 million years, carrying the Sun, Earth, and all their memories through its spiral arms. Within that motion, gravity still acts, but not alone. Every star, every particle of gas is also guided by momentum, by the memory of a universe that began spinning long before the first planet formed. The result isn't chaos, It's order through motion. Gravity builds spheres when left alone, but when paired with rotation, it builds architecture. The physicist and poet alike might find meaning here. Roundness represents peace, the still perfection of gravity unchallenged. Flatness represents persistence, motion, that refuses to stop energy, that insists on surviving collapse. In this way, galaxies are living paradoxes, spherical hearts wrapped in flattened grace. Their centers are ancient and quiet, their edges restless and alive. Together they form the flattened heavens, thin disks of light turning endlessly through the dark. Perhaps that's the universe's secret. Even perfection must learn to bend when it begins to move. If the early universe had been perfectly still, it would have been perfectly empty. But from its first breath motion was woven into its fabric a faint rotation left over from quantum tremors in the newborn cosmos. When gravity began gathering gas into clouds, that ancient spin refused to vanish. Like a note sustained through eons, it carried forward, shaping the galaxies to come. This is the story of angular momentum, the quiet rule behind every whirl, orbit, and rotation in the sky. It's one of nature's strictest promises: what turns keeps turning. The universe does not forget a spin. Imagine a vast, cool cloud of hydrogen and helium 100 light-years across. It drifts aimlessly through the young cosmos, a mist without form. Then gravity notices. Tiny overdensities, places just a little heavier than their surroundings, begin to draw the gas inward. The cloud starts to collapse, but gravity cannot pull straight down in every direction at once. Because the cloud was never truly motionless, there's always a faint trace of rotation, a whisper of angular momentum. And as the radius of the collapsing cloud shrinks, that rotation speeds up. The law is simple: when something contracts, its spin accelerates to conserve total momentum. The same principle lets a figure skater spin faster by drawing in her arms. She doesn't summon energy from nowhere, she simply concentrates it. The collapsing gas cloud does the same. What once turned lazily now whirls like a storm. The rotation flattens the sphere into a disk, gravity squeezing inward, while centrifugal force stretches outward. The tug-of-war creates balance, and in that balance, a galaxy is born. In this swirling sheet of stars and dust, order arises out of collapse. The new galaxy forms a glowing center, a bulge of ancient stars surrounded by spiraling arms that trace the invisible currents of angular momentum. Each orbit is a frozen moment in the dance, each star a step in gravity's choreography. Astronomers call these systems disk galaxies, and they make up most of what we see in the night sky. Our own Milky Way is one of them, a whirlpool of roughly 400 billion stars turning around a central supermassive black hole, completing a full rotation every 230 million years. From above it looks serene, from within it feels eternal. Yet what we're really witnessing is motion locked in memory, the ancient spin of a collapsing cloud still echoing across time. The pattern repeats everywhere across scales from hurricanes to atoms. Spin is the universe's way of storing motion, of keeping rhythm. When air masses on Earth collapse inward toward a low-pressure center, they rotate faster just as galaxies do. A hurricane is a kind of local echo of cosmic law gravity, replaced by pressure gradients, atmosphere replacing interstellar gas, but the same mathematics guiding its dance. At the hurricane's heart, an eye forms a calm, near-perfect circle, born from chaos like a galaxy's core. If you've ever watched such a storm from orbit, you've seen the same geometry at work, spirals of motion feeding on collapse, finding stability through rotation. The difference is only scale. The Milky Way is a storm that takes hundreds of millions of years to complete a single turn. Conservation of angular momentum is more than a mechanical rule. It's a philosophy of persistence. Once set in motion, the universe keeps its memory of direction. Even after collisions, mergers, and disruptions, the total spin remains. Galaxies that crash together often merge into new shapes, yet their combined angular momentum survives, reasserting itself as rotation in the remnant. The cosmos may shuffle the dancers, but it never loses the beat. NASA's simulations of early galaxy formation show this vividly. In the beginning, the protogalactic clouds were chaotic filaments of gas streaming through dark matter scaffolds, colliding and fragmenting. But wherever gravity gathered, matter rotation appeared. Over billions of years, those regions settled into elegant spirals, their angular momentum conserved like a melody, carried through multiple instruments. The result is a cosmic choreography, where every participant knows its step without rehearsal. Stars orbit the center planets, orbit stars, moons orbit planets, an unbroken hierarchy of spin. Even the atoms within our bodies, with electrons whirling around their nuclei, hum to the same rhythm. The dance repeats at every level of being. When you look up at the Milky Way on a clear night, you're not seeing something static. You're watching a motion so immense it appears still the long exposure of creation itself. Every point of light is part of the same slow pirouette that began billions of years ago when the first cloud decided to collapse. Angular momentum turned that collapse into art. Without it, gravity would have pulled matter straight into a single lifeless mass. But with it, the universe learned to spin instead of crash, to transform, fall into flight. There's poetry in that, the idea that balance, not brute force, builds beauty. That motion, when guided by memory, creates harmony. The galaxy's shape is not random. It's the visible trace of endurance. So the next time you see a dancer turning, or a leaf caught in an eddy, or a storm swirling on satellite imagery, remember what you're really witnessing, the same principle that governs galaxies. What began in the first second of the universe has never stopped. Gravity calls inward, momentum carries around. Between them, creation finds rhythm. The cosmos doesn't just move, it remembers. In the great negotiation between gravity and motion, the universe never takes sides. It prefers compromise. Every galaxy is proof of that truce, a marriage of opposites. At its heart, gravity rules. Dense, ancient stars orbit within a roughly spherical bulge, a glowing memory of the first collapse. Around it, motion holds its domain, a thin, graceful disk, spinning outward in slow defiance, preserving the momentum of the cosmos's first breath. The result is neither perfect sphere nor chaotic sprawl. It's something in between, geometry shaped by patience. This is the cosmic compromise. Look closely at any spiral galaxy through the lens of the James Webb Space Telescope, and you'll see that balance written in light. At the center, a golden bulge, hazy but bright, the concentrated glow of billions of old suns packed so tightly that gravity wins over rotation. Farther out, the blue arms of youth filled with newborn stars, their light scattered across a thin rotating plane. Here, motion wins, but only just. It's as if the galaxy were breathing an inward pull toward unity, an outward sweep toward freedom. Even the dust glows softly in the tension between the two. In 2023, Webb peered deeper than any telescope before, into an era when galaxies were only a few 100 million years old. What it found astonished astronomers. Even in that cosmic dawn, disk galaxies already existed, fragile structures spinning in the fog of the early universe. The data showed that gravity and rotation reached their equilibrium astonishingly early, long before galaxies matured into the vast spirals we know. Those newborn disks, faint and glowing, seemed to hover like fireflies in mist caught halfway between collapse and expansion. Each of those proto-galaxies was small, perhaps only a few thousand light-years wide, but the pattern was unmistakable. A bright core, a surrounding disk, the same structure repeating itself across billions of light-years. NASA scientists described them as surprisingly settled, as if the universe, even in its youth, had already discovered a rhythm, a geometry that worked. The Hubble sequence, the way we classify galaxies today, spiral, elliptical, irregular, was already being written then in those early luminous disks. Webb's infrared cameras saw them not as static forms, but as acts in progress, gas-collapsing stars forming dust, cooling, all guided by the twin hands of gravity and spin. It's humbling to realize that what looks peaceful now, the slow, graceful rotation of a spiral galaxy, began as chaos. The first galaxies flickered through collisions and turbulence, their shapes stretched, torn and rebuilt. Yet through that turmoil, roundness and motion kept returning to each other, seeking a shared balance. The universe, it seems, learned early that perfection alone cannot survive, only equilibrium can. Imagine drifting through one of those young galaxies, suspended in the dim light of its forming arms, the airless silence broken only by the faint hum of radiation, the stars around you veiled in dust and gas. Everywhere, tiny points of light shimmer, blue newborns burning hot and brief, red giants swelling and fading. They look like lanterns in fog, billions of cosmic fireflies, glowing through veils of hydrogen. Their light flickers across your visor like breath. If you could watch from above, you'd see the galaxy's shape struggling to decide what it wants to be the center, clinging to its roundness, the edges stretching thin into motion. In that quiet indecision lies the beauty of all creation. The European Space Agency's Gaia mission later mapped our own Milky Way structure with astonishing precision, and even here, billions of years later, the same balance holds. The central bulge remains dense and nearly spherical, home to ancient stars orbiting in slow ellipses, Surrounding it, the thin disk continues its 230 million year rotation, restless, ever spinning its young stars, tracing spiral arms like ripples across a pond. Gravity and motion never stop negotiating, and their compromise is what keeps everything stable. Without spin, galaxies would collapse into featureless spheres. Without gravity, they would unravel into formless clouds. Together they create something enduring, a structure both delicate and resilient, fragile yet eternal. In that balance lies a quiet lesson, one that feels almost human. We too live between opposites, stillness and change, memory and movement. And like galaxies, we find our shape not by choosing one, but by holding both. So the next time you look up and see the faint ribbon of the Milky Way across a dark sky, remember it isn't a perfect circle or a random smear of stars, it's a truce. A luminous signature of the universe learning once again to compromise. Every flat galaxy hides a secret. Beneath its luminous disk of stars and dust lies something we cannot see, a sphere without light, vast enough to cradle everything within it. Astronomers call it a dark matter halo, a roughly spherical shell of invisible mass that extends far beyond a galaxy's visible edges. Without it, the graceful disks of stars we admire could not exist at all. Because here's the paradox: the Milky Way spins so fast that by Newton's laws alone, its outer stars should have been flung into space long ago. The gravity produced by visible matter, all the stars, gas and dust combined, simply isn't enough to hold them in orbit. Yet they remain. They circle quietly century after century, as if anchored by an unseen hand. That hand is the halo. This hidden sphere outweighs everything we can see, 5 times more massive than all the galaxy's visible matter combined. Its gravity sculpts the motion of stars, shapes the arcs of spiral arms, and binds the galaxy together in a cosmic embrace that never loosens. We've never seen dark matter directly. It emits no light, no heat, no radio waves. Yet its influence is everywhere. When astronomers mapped the rotation curves of galaxies in the 1970s, they found a mystery. The stars far from the center weren't slowing down as the equations predicted. They moved with almost constant speed, as if gliding along rails. The only explanation, something invisible, was adding mass where none should exist. Since then, observations by the Hubble Space Telescope Gaia and the James Webb Space Telescope have refined that vision. They show galaxies cocooned in dark halos tens of times larger than their visible disks. If you could see them in full, the Milky Way would no longer look like a silver plate of stars, but like a pearl suspended in an invisible fog, its thin disk glowing at the center of a vast transparent sphere. The European Space Agency's simulations, like the illustrious TNG project, have turned that abstraction into motion. In them, galaxies bloom inside these halos like flowers in glass globes. The dark matter forms first cold clumping under gravity's pull into nearly spherical wells. Then within those wells, gas and dust settle into spinning disks. The halo is the scaffold. The galaxy is the luminous skin. Without that unseen architecture, the spiral arms would tear apart under their own momentum. The bulge would collapse. The balance would fail. Every graceful galaxy you've ever seen owes its serenity to something that cannot be photographed. There's something quietly spiritual about that idea that the visible depends on the invisible. We live inside an act of faith written into physics itself. Every photon we see, every orbit we trace is proof of what we cannot detect. Dark matter is, in a sense, the cosmic equivalent of belief. It doesn't shine, but it shapes. It doesn't speak, but it holds. It keeps the universe coherent even as it remains beyond comprehension. When cosmologists talk about it, their language often softens into wonder. They know only that dark matter interacts through gravity, not light, a silent participant in every cosmic equation. Some theories suggest it may consist of exotic particles, WIMPs or axions. Others hint at modifications to gravity itself. Yet despite decades of searching, detectors buried deep underground or floating in space have found only silence. And still, galaxies move exactly as if it's there. If you could fly beyond the edge of the Milky Way out where the stars thin and the dark takes over, you would still feel the pull of the halo. No glow, no boundary, only gravity, steady and patient like a whisper of belonging. You might look back and see the visible galaxy suspended in the void, glowing faintly at the center of its invisible sphere, a lantern wrapped in glass so clear you'd never know it was there. Every galaxy is built this way, light resting in darkness, motion wrapped in stillness, visible form floating in an unseen sea. It's as if the universe itself understands something we often forget, that the foundation of what endures is rarely visible. The shape that saves the galaxy is the one we cannot see. So when you gaze up at the Milky Way and see that thin ribbon across the sky, remember you are looking not at a flat streak of stars, but at the surface of a hidden sphere, a cathedral of shadow surrounding every point of light. Faith in its purest form is not a belief in what glows, but a trust in what holds it there. When you first see a spiral galaxy, it's easy to believe the arms are solid like rivers of stars frozen in motion. But they're not. They are waves, not walls. And what you're really seeing is music written in matter. In the mid-20th century, astronomers puzzled over why spiral arms stay intact for billions of years. If the arms were made of the same stars forever, they should wind up tightly like a coiled spring and disappear, yet they persist as elegant as ever. The solution came with the density wave theory, a quiet revelation in galactic physics. The spiral arms are not permanent structures. They are patterns of compression moving through the galactic disk like sound waves through air, or ripples across a pond. As the wave passes through, it slows the motion of nearby stars and gas, piling them up temporarily before letting them move on. The result is a cosmic traffic jam of starlight matter, flowing freely but appearing to cluster in luminous spirals. Where the gas compresses, new stars ignite glowing blue and short-lived the beacons that trace the arm's path. NASA's simulations show these waves sweeping through the Milky Way like chords plucked on a vast harp, each arm a note that resonates for hundreds of millions of years before fading into harmony again. The galaxy, in other words, plays itself. If you could hover above the Milky Way, the sight would be mesmerizing. The central bulge would glow golden, surrounded by faint curving arms of dust and stars. Through the haze, you'd see flickers of light forming and fading, birth and death woven into motion. The arms would seem to turn like the grooves of a record, yet nothing in them truly stands still. Every particle of gas, every star, every grain of dust moves through these zones of compression, briefly illuminating the path before drifting onward. The mathematics of these density waves resemble the physics of sound regions of higher density travel through lower density surroundings carrying energy without carrying matter. In this sense, a galaxy is a symphony of gravity, and we are listening to it in slow motion. Einstein once called the universe a frozen music. Here that phrase feels literal. Human cultures have long felt something sacred in the spiral. Long before telescopes, we carved and painted that shape into stone and memory. The Celtic Triskel, 3 interlocked spirals, symbolized motion, unity, and eternal return. In Maori art, the kuru, an unfurling fern frond, stands for growth, renewal, and peace. In Buddhist mandalas, spirals represent the path of awakening the soul, moving outward in compassion or inward toward stillness. Everywhere we find the same intuition that the spiral is life's signature motion, without chaos, order, without rigidity. The galaxy viewed from afar is the ultimate expression of that idea. Its arms are not mechanical but organic spirals of transformation, forever moving yet forever whole. The same geometry that shapes seashells, storms and flowers repeats across light years, suggesting that the universe has a rhythm that echoes through every scale. Think of it this way: as the spiral wave sweeps through it, invites matter to pause, to glow, to participate briefly in the grand design before continuing on its way. Stars form, shine and die, yet the pattern remains an ongoing song that outlives its instruments. The spiral is both path and pause. It is how galaxies remember motion without losing grace. It is how gravity once again turns mathematics into beauty. Stand beneath the night sky on a clear evening and you might sense that rhythm. The Milky Way above you is not a static band, but a moving harmony, its arms advancing so slowly that human eyes will never notice. Yet the pattern endures a record, spinning through eons, an unending refrain. Across cultures, across time, we've painted, sung and dreamed of this curve, because something in it mirrors ourselves. We too live in spirals, circling through change, returning to balance, finding music in repetition. And somewhere between the pull of gravity and the freedom of motion, the universe hums the same refrain that everything which endures must also move, and everything that moves can still find its center. In about 4 billion years, 2 galaxies will meet across the dark gulf of space, not as enemies, but as dancers whose orbits have finally intertwined. One is our home, the Milky Way. The other, Andromeda, a slightly larger spiral approaching at 110 kilometers per second. From our small planet, it looks eternal, a pinwheel of light so distant it might never change. But the universe is restless, and even galaxies are destined to collide. Astronomers have already seen this future unfold in computer simulations, silent ballets of gravity rendered over billions of years. First comes the slow draw. Andromeda grows larger in the sky, its spiral arms no longer faint, but luminous, stretching from horizon to horizon. The two disks begin to distort their outer edges, drawn into luminous bridges of stars. Then contact. Gas and dust collide. Stars are thrown into elongated arcs, some flung outward, some spiraling inward toward the joined heart. But despite the drama, few individual stars will actually strike one another. The distances between them are too vast. The real collisions happen in the invisible medium gas compressing heating, igniting new waves of starbirth. Whole clusters will blaze to life as the galaxies interlace. For a few 100 million years, the night sky from any surviving planet would be a wonder beyond comprehension. Great rivers of starlight crossing the heavens, two cores entwined like lanterns in fog. Then slowly the chaos would subside. When NASA and ESA scientists ran simulations of this event using data from the Hubble and Gaia missions, they discovered that the final product of this grand encounter will not be a spiral at all. The delicate disks, the elegant arms, all will dissolve. The spin that once defined each galaxy will begin to cancel as billions of stars exchange momentum through gravity's ceaseless mediation. The result, a new rounded galaxy, what astronomers call an elliptical, spherical, luminous calm. A return to the shape gravity has always loved best. It's a process not of destruction but of recycling. The two spirals will merge their stars, their black holes, their histories and their motions into something simpler, a single, glowing sphere, perhaps called Milky Way, where the remnants of both still shine. The sun by then, an aging red giant, will long have faded, but the legacy of our spiral home will live on, dissolved into a new geometry of light. Astronomers have already glimpsed similar mergers elsewhere in galaxies like NGC 2623 or the Antennae galaxies, where long tendrils of stars stretch across space like filaments of silk. Each is a chapter in the same cosmic cycle, spin, flattening, union, return. If you could watch this slow event from afar, sped up over eons, it would look almost alive. Two disks spinning together, their arms entwining their centers, glowing brighter with every pass. For a moment they seem to resist spirals, clutching their identity, and then gradually they give way to gravity's deeper demand. The swirling fades, the light rounds, and stillness resumes. Every collision in the cosmos ends this way in balance. Motion expends itself, angular momentum finds its match, and the system settles once more into the timeless serenity of the sphere. Galaxies are not destroyed when they collide, they are reborn. The old stars mix with the new, the gas forms fresh worlds. The dark matter halos blend into a larger unseen architecture. It is chaos transmuted into order, entropy finding beauty in surrender. When the Milky Way and Andromeda finally merge, their central black holes will also spiral together, releasing titanic waves of gravity ripples that will echo through space-time, perhaps heard by civilizations yet unborn. And when the last wave fades, when the orbits align and the light smooths out the universe, will have composed another masterpiece of equilibrium. From dust to spin, from disk to sphere, the cycle completes. In the end, there are no permanent forms, only returning shapes. The spiral gives way to roundness, the song resolves into silence, and as always, the final note of the cosmic symphony is the same. When spin cancels, roundness returns. Is the universe itself round or flat? It sounds like a child's question, but it is one of the deepest puzzles in cosmology. After all these spiral spheres and invisible halos, what shape contains them all? To approach that question, scientists turn to the oldest light in existence, the cosmic microwave background, or CMB. It's the faint afterglow of the Big Bang, released when the universe was just 380,000 years old, long before stars, before galaxies, before anything we might call structure. When the Planck satellite mapped that ancient light in exquisite detail, what it saw was astonishingly simple. A soft mottled pattern of temperature differences no greater than 1 part in 100,000. It was in essence a map of the baby universe still glowing faintly across the sky. To the human eye, the image looks like a woven fabric, tiny red and blue, blotches scattered across an oval frame, a cosmic portrait of the first ripples that would one day grow into galaxies. But within that faint texture lay a geometric truth. By measuring how those ripples stretched across the sky, scientists could infer the curvature of space itself, whether the universe bends inward like a sphere, outward like a saddle, or lies flat as an infinite plane. The result, flat, astonishingly flat. According to Planck's measurements, the curvature of space is so close to zero that on the largest scales, parallel lines never meet light rays travel straight, and the universe behaves like a vast uncurved sheet, though one that expands, stretches, and folds in time. The conclusion was both comforting and strange. After billions of years watching gravity mold roundness into stars and planets, we discovered that the stage on which all that roundness plays out is itself almost perfectly flat. It's a paradox of cosmic proportion, local curvature, everywhere global symmetry overall. The universe makes spheres inside a plane. That flatness scientists believe was sculpted in the universe's first instant during the inflationary epoch, when space expanded faster than light for a brief inconceivable moment. Inflation stretched any initial curvature until it smoothed out like a taut fabric. The same process froze in the quantum ripples we now see as the CMB's gentle mottling. Imagine it visually. A vast translucent map fills your field of view, the sky itself transformed into a glowing tapestry of colour. The pattern wraps around you, faintly humming in microwave frequencies, the echo of a time when everything matter-light-space was one. That glow is still here, bathing Earth from every direction, invisible but ever-present, a temperature of just 2.7 kelvins above absolute zero. Every photon of that light has been travelling for nearly 14 billion years, carrying the memory of the universe's first geometry. The Planck mission showed that the flatness is not absolute. Small deviations may exist like ripples in a vast lake. But the overall balance holds gravity and expansion so finely tuned that the cosmic fabric neither curls inward nor tears apart. It is once again a compromise between the pull of matter and the push of dark energy, between the desire to collapse and the will to expand. From galaxies to the cosmos itself, the same theme repeats: motion and stillness, curve and line, roundness and flatness held in delicate tension. If you could see it all at once, every cluster, every filament, every void, you'd find not a sphere or a cube, but a great cosmic web, stretching across space like frost on glass. Each galaxy is a bead in that net, glowing faintly, connected by invisible threads of gravity and dark matter. From afar, it resembles the CMB map that birthed it, the same pattern, amplified and evolved. The baby universe, all grown up, still remembers its earliest geometry. Perhaps that's the final lesson geometry has to give us. Roundness and flatness are not opposites, but partners in an endless balancing act. The universe curves locally to create, flattens globally to endure. And through it all, that faint background light, the soft echo of the first dawn, still glows around us, whispering the same quiet truth. Everything we see began as a ripple on a perfectly even sea. For something so immense, the universe feels surprisingly familiar. You can draw a triangle with its corners billions of light years apart, and the angles still add up to 180 degrees. Light travels straight, not curved. Parallel beams never meet. Across distances beyond comprehension, Euclid still rules. This is the great surprise of modern cosmology, that space on the larger scales behaves as if it were flat, not bent like the surface of a sphere, or warped like a saddle, but nearly perfect in its geometry. To understand what that means, picture yourself sailing across an endless ocean. From the deck, the sea seems perfectly flat, the horizon steady, the waves stretching straight into forever. You know, of course, that Earth beneath you is round, but its curvature hides beneath distance. Only when you sail far enough, when the ship disappears hull first beyond the horizon, do you realize that flat was only an illusion of scale. The universe works the same way, only in reverse. Locally, gravity creates curves everywhere, planets, stars, black holes, the bends of space-time that make orbits possible. But step back far enough, measure across billions of light years, and those curves average out. The cosmic ocean smooths, the horizon looks flat, and that smoothness isn't accidental, it's ancient. In the late 1970s, physicist Alan Guth proposed a radical idea to explain why the universe appears so even and flat cosmic inflation. According to his theory, in the first tiny fraction of a second after the Big Bang, around 1035 seconds, the universe expanded exponentially faster than the speed of light. A region smaller than an atom ballooned into something vast enough to encompass everything we can now see. That explosive, stretching, flattened space, the way a balloon inflates until any wrinkles vanish. Whatever curvature the early cosmos may have had was ironed out by expansion itself, leaving behind the calm geometry we inhabit today. Inflation didn't just smooth the universe, it seeded it. Quantum fluctuations, microscopic jitters of energy during that rapid expansion, were magnified into macroscopic ripples in density. Those ripples became the blueprint for galaxies' clusters and the great cosmic web we now observe. NASA's WMAP and Planck missions later confirmed this picture with exquisite precision. The tiny variations in the cosmic microwave background match what inflation predicted, nearly scale-invariant fluctuations evenly distributed across the sky. The data tell a consistent story. The universe is flat to within 0.4%. If you could fire a laser across the cosmos, it would never converge or diverge. It would glide endlessly, tracing an invisible straight line through expanding emptiness, in a way that makes our entire existence possible. A slightly more curved universe would have collapsed back into itself long ago. A slightly less curved one would have expanded too quickly for stars to form. Flatness, it seems, is not just geometry, it is balanced survival, the razor-thin harmony between gravity's pull and expansion's push. There's something almost philosophical about that precision. A cosmos so vast yet tuned with the delicacy of a compass drawing a perfect circle. Mathematically infinite yet steady enough for atoms, planets, and thought. To sail across such a universe is to move through an ocean that feels endless and level, though you know beneath its still surface lie hidden curves, the gravity wells of stars, the dimples of galaxies, the unseen tides of dark energy. Every direction looks the same. Every journey begins and ends on what feels like a plane, and somewhere in that quiet, flat expanse we stand brief travelers on a deck of light, tracing straight paths across a sea so vast it hides its curvature from view. Inflation gave us that sea. Geometry keeps it calm. In a universe that could have been chaos, the greatest wonder may be its flatness, a silent stretch so evenly that everything inside it can sing. Before galaxies, before atoms, before even light itself, the universe took a single breathtaking breath. In that instant it expanded so fast that words like speed and distance no longer applied. It was not an explosion in space, it was space itself exploding, stretching, doubling, redoubling faster than light could ever hope to follow. Physicists call this moment inflation, and it changed everything, not just the size of the cosmos, but its shape, its smoothness, its destiny. To imagine it, think of a balloon. Draw tiny dots across its surface. Those dots aren't moving over the balloon, they're being carried apart as the balloon itself expands. In the same way, galaxies today are not flying through space. They're embedded in space, carried apart as space stretches. Now imagine the balloon inflating so violently that in less than a trillionth of a second, something smaller than an atom swells to the size of a grapefruit and keeps going. Any wrinkles or bends on its surface smooth out instantly just as a balloon's rubber flattens as it grows. That's what inflation did to the early universe. It stretched curvature into near perfection. Whatever shape space-time once had, sphere-saddled chaos inflation expanded it so dramatically that any local curvature became imperceptible. From within it would look flat, endless, and calm. Even now, nearly 14 billion years later, we still live inside that illusion, a cosmic horizon that appears boundless and without edge, because inflation pulled every possible edge beyond reach. Alan Guth, the quiet theorist who first proposed this idea in 1980, once described it with a mixture of awe and humility. It's not that the universe grew into empty space, he said. Space itself grew faster than light, faster than imagination. Inflation violated no law of physics because it was not matter outrunning light, but the fabric of space expanding. And as it did, it left faint fingerprints, quantum ripples, magnified to cosmic scales, frozen as density variations that we now see as the mottled pattern of the cosmic microwave background. That soft glow across the sky, the afterimage of creation, is inflation's memory still whispering through every radio telescope that listens. There's something profoundly peaceful in that thought, that all the complexity, all the curvature and chaos we see today began as a moment of astonishing simplicity, a field of energy expanding faster than light, ironing the universe smooth. Inflation didn't just create size, it created silence, the uniform background against which galaxies could later form their music. If you could have watched from outside, though outside has no meaning here, you would have seen a brightness expanding into itself, a glow with no center and no edge, a sphere that wasn't really a sphere but the totality of space. The universe had no borders, only extension. Everywhere was the middle. Even now, the illusion of flatness remains one of inflation's most enduring gifts. We gaze into the night sky and see no boundary, no curvature, no edge to fall from. The same light that once filled every corner of existence now arrives in quiet photons, reminding us that the infinite can arise from the infinitesimal. Inflation teaches that the universe has no edge because every point expands equally a truth both scientific and serene. When you stand beneath the stars, what you feel as vast emptiness is actually continuity, a single stretch of space-time still unfolding from that first breath. And in that calm lies wonder itself, the realization that what looks like forever may simply be the smallest curve drawn so wide that no eye, no telescope, no lifetime could ever see its end. There is a limit to how far we can see, not because the universe ends, but because light hasn't had time to arrive. That boundary is called the cosmic horizon, and it defines the edge of the observable universe, the greatest circle our instruments and physics can draw. Beyond it, light has been travelling since the first dawn, and still it hasn't reached us. At present, that horizon lies about 46.5 billion light-years away in every direction. Inside it lies everything we can observe, all galaxies, clusters, dark matter, filaments, an island of visibility in an ocean without map. Outside it, the rest of reality unlit and unreachable, expanding faster than any signal we could ever send. Astronomers sometimes call this horizon the ultimate frontier of knowledge. It's not a wall, just a limit imposed by time itself. The photons that form the cosmic microwave background have been on their way for 13.8 billion years, stretched thin by the expansion of space. Beyond that, whatever exists remains invisible perhaps forever, and yet the idea of a horizon feels deeper than physics. To sailors, the horizon is promise, and mystery, the line between what is known and what might still be found. To mystics, it's the veil between awareness and the infinite. To scientists, it's both a measurable distance and a philosophical invitation. Our cosmic horizon is the same, a boundary of perception, not of existence. It humbles and inspires in equal measure. From Earth, we already listen to the universe at its limits. The James Webb Space Telescope peers back over 13 billion years, seeing galaxies in their infancy. The next generation, NASA's Nancy Grace Roman Telescope, due to launch later this decade, will widen that view, surveying millions of galaxies at once, tracing dark energy's fingerprints on cosmic expansion. Farther ahead, the Laser Interferometer Space Antenna LISA will open a new sense, entirely detecting gravitational waves from merging black holes across billions of light years. Together they will let us hear beyond what we can see, turning the universe into both map and melody. Each mission pushes the horizon outward, not by moving it, but by sharpening the circle of the known. If you could stand outside our cosmic bubble and look back, you'd see a sphere of faint light like a candle floating in an infinite fog, the observable universe glowing from within. To us, inside that boundary is everywhere at once. No matter where you look, it forms the same perfect distance. The horizon is round because time itself is round, enclosing all possible sight in a single symmetry. But what lies beyond, perhaps other regions with different laws, other inflating bubbles adrift in a larger multiverse. Or perhaps the universe simply continues smooth and endless without boundary. We may never know, and that too is part of its beauty. Because every horizon, scientific or spiritual, exists to remind us of humility, that the unknown isn't an absence but a direction, a place where curiosity still lives. So when you look up at the night sky and imagine its edge, remember this: you're seeing the inside of a growing bubble of awareness. Every photon caught by a telescope is a whisper from within that 46 billion light-year sphere. Every discovery expands the circle of light just a little more. And perhaps that is what the universe intends, that we should never reach the end, only the next horizon. Perhaps we walk the inside of a cosmic bubble, flat beneath our feet, endless to our eyes, yet curved in ways no ruler could reveal. For all the precision of modern cosmology, flatness may be an illusion of scale. The Planck mission, the WMAP survey, and the mapping of distant galaxies all point to a universe whose geometry is astonishingly even, but not necessarily perfectly so. The margin of uncertainty still leaves room for a whisper of curvature, a bending too vast for us to measure from within. If the cosmos were slightly positively curved, it would resemble the surface of a four-dimensional sphere, a hypersphere, its geometry looping back on itself. In such a universe, travel far enough in one direction, and given infinite patience, you might return from the opposite side, as if crossing the surface of a globe. If instead it were negatively curved like an infinite saddle space, would expand forever every triangle's angles, adding up to less than 180 degree parallel lines, diverging as they chase each other into infinity. Either way, our instruments can't yet tell the difference. At scales smaller than the observable universe, 46 billion light-years in every direction, the curvature is so faint it hides beneath the noise of measurement. To us, the world appears Euclidean, obedient to straight lines and flat geometry. But on a grander level, space may still be folding gently around itself, a cosmic smile just beyond detection. Physicists describe these possibilities with quiet awe. Some see curvature not as a feature of a single cosmos, but as evidence that our universe may be one bubble among many a droplet in an endless cosmic foam. Each bubble could carry its own laws of physics, its own balance of matter and energy, its own version of light and time. In this view, the multiverse hypothesis inflation never truly ended. It continues elsewhere, eternally spawning new pockets of space-time, each expanding into its own horizon. We might never meet those other realms. Their light will never reach us sealed beyond our cosmic shore. But the thought itself changes how we see this one. It reminds us that even the word universe, once meaning all that exists, may be too small. Imagine then our flat sky as the inner wall of a vast invisible sphere. We are ants walking along the inside of a balloon so immense that its curve feels straight beneath our steps. Light-like sound on that surface follows geodesics too gentle to notice. To us the horizon looks infinite. To the universe it is simply continuous. There's a strange comfort in that image. It means there is no center, no edge, no preferred place, only participation. Every point expands equally. Every observer sees themselves at the middle of their own sky. And yet if space truly folds back upon itself, we are never as far apart as we think. Every line we draw extended long enough may circle home. NASA and ESA missions continue to refine this question, measuring the faint distortions in the cosmic microwave background, tracing gravitational lenses that could betray hidden curvature. So far, the data whisper the same refrain, flatter still. But the possibility of a gentle curve persists, a reminder that perfection in science is always provisional. Perhaps that's the beauty of it, the sense that we live inside something slightly larger than comprehension. A geometry not quite straight, not quite closed, but forever poised between the two. So as you stand beneath the night sky under stars that arc with quiet precision, imagine that you are walking across a curved plane so immense it pretends to be flat. Every beam of light, every wave of gravity, every heartbeat you feel is tracing a line along that hidden contour. And somewhere beyond measure, the curve completes itself a circle so vast that even infinity cannot see its edge. Perhaps we walk the inside of a cosmic bubble, and perhaps that bubble too is only one note in a larger harmony. When we call the universe flat, we're speaking in approximations. The truth, as Einstein showed, is subtler space is curved wherever there is mass or energy. The Sun, Earth. Every galaxy all bend space-time around them like stones resting on an invisible fabric. Gravity in this deeper sense isn't a force pulling objects together, it's the geometry of motion, the way straight lines bend in response to existence itself. And yet, from where we stand, it feels flat. To understand this paradox, think of Earth. To someone walking across a field, the ground seems level endless in every direction. But climb high enough, and the horizon reveals its arc proof that the flat world is only the small view of a traveler within a larger curve. Space behaves the same way. Relativity tells us that mass curves space-time, but the scales of that curvature vary enormously. Around Earth, the bending is strong enough to guide satellites. Around the Sun, it shapes orbits and delays starlight. Around black holes, it becomes almost absolute. Yet across the vast expanses between galaxies, those curvatures average out to near zero. Locally curved, globally smooth, the illusion of flatness born from perspective. Einstein once wrote that space tells matter how to move. Matter tells space how to curve. Every planet, every atom participates in this dialogue. You are bending space-time right now infinitesimally just by being. If we could visualize it, the cosmos would look like a vast ocean with gentle swells and deep troughs. Gravity wells sculpted by stars, waves rising where clusters of galaxies gather, calm plains stretching through cosmic voids. From far away, those swells disappear into smoothness like the round Earth seen from the moon, complete balance, serene. Now imagine a traveler sailing through that sea. To them the waters seem flat. Their compass points straight, their course steady. They could travel forever in what feels like a straight line, yet after uncountable eons they might find themselves returning to the place they began, never realizing that straight was simply a path along a curve too vast to perceive. That is relativity's quiet revelation. Flatness is a local illusion within a curved hole. It is not false, only incomplete. NASA visualizations of gravitational lensing show this beautifully light from a distant galaxy, bending around a massive cluster, its image multiplied and stretched. To the photon, its path is perfectly straight. To us, it arcs like a ribbon through curved space. The contradiction dissolves when we accept that straight and curved are matters of vantage. Einstein's equations hold both truths at once, the small and the grand, the local and the cosmic. We live within curvature, yet measure flatness, and both are correct depending on where we stand. Poets might call this the geometry of humility. From our narrow decks on the cosmic sea, everything seems even predictable mapped. But the farther we sail, the more that stillness reveals its hidden arc. We're always returning slowly and visibly to the place we began. So perhaps the universe is less a straight road and more a voyage without edges, a round trip disguised as infinity. And every time light completes its loop around a star or a galaxy, curves space into a spiral, it whispers the same quiet reminder. What feels flat is only part of a curve too grand to see. From far enough away, the universe looks like it has learned to draw with curves. Not the simple arc of a circle, but a living lattice of bends and swells, clusters at the intersections, filaments stretching between them, and vast voids ballooning like bubbles of night. Astronomers call it the cosmic web, but it might as well be a cosmic tissue, a cellular geometry grown from gravity's patient work. In this grand foam mass flows along the strands, pulls at the nodes and leaves caverns where almost nothing remains. Space itself seems to bow around the crowded places and relax across the empty ones, a topography of curvature written in light and absence. Look at a galaxy cluster, the bright knotted heart where thousands of galaxies gather. The mass there is so great that space-time dimples and background galaxies are smeared into arcs and rings by gravitational lensing. A photon crossing that field thinks it is going straight. We watch its path bend like a river around a headland, step away from the knots and follow a filament out into the dark, hundreds of millions of light years long, only a few million light years thick. A braided highway of dark matter, hydrogen and warm plasma. Gas streams along these strands like dew collecting on a spider's silk feeding star formation in the galaxies that cling to the filament's spine. Then the strand opens into a void and the geometry loosens. Galaxies thin, gravity's hand grows light and space wears a quieter curve. The universe breathes here pressure and pull fullness and hollowness, all sharing one architecture. The illustrious and illustrious TNG simulations render this dance in time-lapse. Seed the early universe with tiny ripples, the quantum fingerprints left by inflation, and let gravity run for 13.8 billion years. The faint becomes filament, the filament thickens into cables. The cables tie themselves at nodes swollen into clusters. Gas cools along these strands, falls inward shocks and warms, radiates, cools again. Cyclical thermodynamics etched onto geometry. In those digital skies you can watch galaxies migrate along the filaments, like birds following invisible jet streams merging at the nodes to build the larger structures bound by gravity. Geometry is not background decoration. It is the conveyor of growth. The James Webb Space Telescope peers into the early epochs and finds the web already sketching itself. In deep fields, faint smudges resolve into protoclusters, embryonic nodes linked by gauzy bridges of matter. The same pattern we map nearby is present just a few 100 million years after the Big Bang, like a fossil unfurling in reverse. Webb's infrared eye reveals that young galaxies are not isolated candles. They are capillaries in a larger tissue, their starbursts timed by flows along filaments and by the crush of gathering nodes. Where the curves tighten, galaxies flare. Where they loosen, galaxies dim. Even the afterglow of creation the CMB bears witness its photons slightly boosted or drained by travelling through growing wells and expanding voids, a faint integrated Sachs-Wolf echo of curvature changing with time. Stand the universe beside a forest, and the resemblance is more than poetic. The mycelial networks beneath soil, the branching of river deltas, the axons and dendrites lighting a brain scan. Each is a web that optimizes flow with minimal cost. Physics calls this tendency least action and energy minimization. Life calls it survival. The cosmic web solves the same problem at unthinkable scales, how to move matter efficiently from diffuse beginnings to bright concentrations without wasting motion. Filaments lower the cost of travel for gas. Nodes lower the cost of binding for galaxies. Even the voids have purpose. They are the release the counterbalance that lets the rest intensify. You can feel the curvature without math if you imagine roaming it. Drift toward a cluster background galaxy's halo into arcs. The microwave sky grows subtly brighter as photons fall in and climb out of the deepening well. Traverse a filament. Galaxies align their spins gently biased by the strand, their halos elongated along the route of flow. Enter a void. Distances stretch, peculiar velocities relax, and you sense the universe exhale. This is not flatness, ignoring gravity. It is flatness braided by curves and average Euclid threaded with relativity's embroidery. The web's geometry guides destiny. Galaxies nourished by steady filamentary infall keep forming stars. Those stranded in the thin places fade. At the nodes, mergers spike central black holes fatten, and feedback winds puff hot bubbles back into the strands, recycling not ruin. The largest arcs of lensing mark the densest knots. The straightest sightlines cross the quietest voids. Even dark energy, the slow pressure expanding the whole, modulates the web's tension, letting voids swell while clusters grow more deliberate. Geometry and growth are one equation. Perhaps that is why the sight of a spiral arm, a branching tree and a river delta touches the same chord. We recognize the recurring design paths that curve because curves distribute load, networks that branch because branching shares risk, membranes that bubble because bubbles minimize surface for a given volume. The universe from neurons to nebulae chooses shapes that conserve effort and preserve flow. What we call beauty may be our intuition catching physics in the act. In the quiet of night, picture the Milky Way as just one bead on a titanic lacework our local group tugged along a filament toward the Virgo cluster itself, a node on a still larger strand leading into the Laniakea supercluster's basin. We are not falling into a point. We are following a curve on a map without edges. The same geometry that holds droplets into spheres and galaxies into disks has scaled up into a web that holds everything flexible, efficient, alive with motion. The cosmic web is the universe's handwriting, clustered loops, sweeping ligatures, generous white space. To read it is to learn that curvature is not an exception to flatness but its frame, that emptiness is not absence but structure, and that the shapes which cradle life on Earth are rehearsals of a geometry that spans the sky. We do not live beside this web, we live inside its cells in a larger body carried along by the same patient curves. Roundness in the end always wins. No matter how the universe twists or tears, how stars flare and die, how galaxies collide and scatter, gravity never stops smoothing. It is the most patient sculptor in existence, a silent artist that carves not with force, but with time. Every jagged edge, every asymmetry, every burst of chaos eventually yields to its touch. In physics, the reason is simple yet profound. A sphere is the lowest energy shape that matter can take when governed by its own gravity. Any irregularity, any bulge or corner creates imbalance regions, where gravity pulls harder here, weaker there. Over time, those imbalances correct themselves. Mountains erode, planets round, stars settle. The universe seeks equilibrium not because it wants to, but because it cannot help it. You can see this truth everywhere. A droplet of water in freefall becomes a perfect bead. A newborn planet, molten and malleable, draws itself into a globe. Even the titanic clouds of interstellar gas left to collapse spiral into dense orbs of plasma that will one day ignite as suns. The math says all the surface area of a sphere is the smallest possible for a given volume, minimizing energy, maximizing stability. In a cosmos built on efficiency, roundness is nature's shorthand for peace. It's easy to think of gravity as fierce, crushing, violent, relentless, but its deeper nature is gentler, more deliberate. It doesn't destroy what it shapes, it simply waits. It will wait 1 billion years to turn a sharp rock into dust, a restless galaxy into a smooth, elliptical glow, a chaotic nebula into the calm of a star. Gravity's patience is infinite. It does not rush, it does not tire, it simply continues. When galaxies merge, the spiral arms tangle and warp, but in time the chaos resolves into a round, luminous form. When supernovae scatter elements into the void, their fragments will eventually slow, cluster and curve again into new worlds. Even the fierce symmetry of a black hole round absolute silence is the final act of this same slow choreography. Roundness is how the universe remembers what balance feels like. NASA's long exposure surveys, Hubble's deep fields, Webb's early galaxies show this pattern written everywhere. In the youngest galaxies, shape is still negotiable, elongated, lumpy, awkward. But as they age, the edges soften, the spin distributes the light pools into halos. The lesson repeats: time erases sharpness, chaos surrenders to contour. If you could speed up cosmic time, watch eons unfold like seconds, you would see everything moving toward the same geometry. Stars flicker, fade, and fall back into round clouds. Galaxies collide round again. The web itself stretches its filaments, tugging toward nodes that grow more spherical as they fill with light. It's less a story of dominance than of endurance. Roundness wins not by conquering, but by waiting longer than everything else. There's something meditative about that inevitability. The same patience that forms planets also teaches perspective. Every curve in the universe, each droplet, moon, and cell exists because something chose stillness over struggle. In that sense, gravity and serenity are twins. Both draw things inward, both smooth roughness, both turn motion into rest. And perhaps that is why we find circles and spheres so calming. They are the shapes of completion of balance restored after motion's long journey. So when you hold a pebble, look at a planet, or trace the halo of a distant star, remember you are witnessing the end of struggle made visible. The slow triumph of patience over turbulence. The form that everything given time enough will return to. Roundness is the universe at peace with itself, a whisper that no matter how far things fall apart, they will in the fullness of time find their way back into symmetry. Gravity never sleeps. It only waits until everything everywhere remembers how to be whole. The universe has never been fond of corners. Wherever a sharp edge appears, physics begins its quiet work to soften it. The cube is a choice temporary, deliberate, imposed. The sphere is a law, the inevitable consequence of time. In the language of physics, discontinuities are expensive. They trap stress, concentrate force, store energy in imbalance. Nature dislikes imbalance. It finds ways to spread it out, to dissolve gradients, to let energy flow until no tension remains. It's the same reason cliffs crumble, why lightning forks instead of striking in a perfect line, why rivers curve instead of running straight. Every process in the cosmos bends towards smoothness. The second law of thermodynamics gives this preference a name: entropy. It tells us that isolated systems evolve toward uniformity, energy dispersing temperatures, equalizing surfaces, eroding extremes, fading into averages. Entropy is not chaos. It is the art of leveling, the patient removal of contrasts. Over enough time, even the fiercest mountains become rounded hills, their sharp ridges surrendered to gravity, wind, and rain. Stars burn unevenly, flare and fade, but their ashes spread evenly into the interstellar medium, seeding the next generation of round worlds. You can see the same law at every scale. A snowflake's sixfold symmetry is fragile. One warm breath and its crystalline spikes melt into a single droplet. A broken shard of glass left long enough on a beach becomes a smooth sea pebble, the ocean's tide polishing it with unthinking rhythm. Even the boundaries between subatomic particles blur at quantum scales, where certainty dissolves into probability and edges become waves. In thermodynamics, this drive towards smoothness is expressed mathematically as minimization of free energy, the system finding its lowest possible stress. In geometry, it takes the form of the sphere, the shape with minimal surface area, for a given volume, the perfect expression of economy. Everything that can round off eventually will. The Earth's continents once shattered in violent collisions, yet every coastline today has the same fractal grace, the product of endless correction. Even human architecture must obey. The sharpest skyscraper corners require weatherproof rounding. The hardest blade must be honed smooth to cut cleanly. Sharpness in a universe that values balance survives only as an act of maintenance. Look to the heavens, and the same principle reigns. Galaxies collide and blend, their jagged streams of stars absorbed into halos of light. Supernova shockwaves spread outward as perfect spheres. Black holes erase edges altogether, replacing boundaries with smooth event horizons, where gradients of space and time become inseparable. The cosmos does not tolerate abruptness. It replaces it with gradients, continuous transitions between states, between hot and cold, full and empty, dark and bright. Even light itself fades gently at its edges, following an inverse square law that ensures no beam ends abruptly, only weakens into forever. Entropy is often misunderstood as destruction, but it is closer to forgiveness. It removes sharp divisions, returns contrast to continuity, lets tension dissolve into peace. The same process that wears mountains down also cools stars and calms galaxies. It is the universe's slow exhale, its way of saying, "Let there be rest." Perhaps that's why we find sharpness unsettling and curves soothing. Edges suggest effort, precision, resistance. Curves suggest acceptance. When we draw circles, we echo the cosmos' favourite compromise between tension and ease. When we build cubes, we imitate its defiance, and then must spend energy to maintain them. In that sense, civilization is angular. The universe is round. Our geometry is an act of will. Nature's is an act of patience. We can construct squares, pyramids, lattices, but leave them long enough and rain heat and time will return them to dust and curve. So when we say the universe hates sharp edges, we mean that it resists them the way water resists stillness, by moving until balance returns. From atoms to continents, every boundary softens, every contrast fades. In the end, what survives are gradients, not walls, horizons, not fences. The cube is a choice, the sphere is a law, and time is the quiet hand that enforces it, rounding, smoothing, forgiving, until everything finds again the shape of rest. It takes no color, makes no sound, and leaves no trail, yet gravity is the quiet pulse behind everything that endures. It is not a force in the old sense, no invisible rope, pulling planets through void, but geometry and motion, the curvature of space and time responding to the presence of mass and energy. Einstein replaced Newton's mysterious attraction with something deeper and more graceful. Matter tells space-time how to bend, space-time tells matter how to move. Drop a marble on a stretched sheet and the fabric dips around it. Roll smaller marbles nearby and they spiral inward, not because the larger marble reaches for them, but because the surface itself curves. That is the universe's true shape, a flexible stage, not a static one. We see this every day, even if we don't notice. A stream of droplets floating aboard the International Space Station will drift together, merge and round themselves into perfect spheres. Watch long enough, and those droplets will begin to dance, orbiting, colliding, absorbing miniature echoes of planets finding their balance. No one commands them, the geometry itself does. On Earth we feel gravity as weight as the press of the ground beneath our feet. But out there between stars it is more subtle, a continuous conversation between every object and the fabric that contains them. Each star, each planet, each atom depresses the cosmic fabric a little, contributing to the universal choreography. Nothing exists in isolation. Everything participates in the bending of everything else. When you look at an image of gravitational lensing light from a distant galaxy bent into arcs around an unseen cluster, you are witnessing geometry at work. Photons have no mass yet. They follow the shortest possible path through curved space, looping gracefully around the distortions created by matter. Space and time are not merely containers for reality, they are active participants. Without gravity's constant curvature, nothing would cohere. No galaxies, no stars, no orbits, only particles racing apart into silence. Gravity in this sense is the universe's handwriting, a script drawn not in ink but in direction. It links the smallest to the largest, the briefest to the eternal. When we drop a stone, it falls along the same law that binds galaxies to their clusters, black holes to their halos. The same equation, simple, profound, runs through all scales, harmonizing chaos into structure. Physicists call it the weakest of the fundamental forces, but perhaps that's a misnomer. Gravity's power lies not in strength, but in persistence. It doesn't push or shout. It waits, accumulating over time, assembling the architecture of everything we see. It sculpted the stars that built our atoms, the planets that harbor our breath, the tides that measure our hours. Its patience spans eons. There is a humility in that patience. Unlike electromagnetism, which vibrates and sparks gravity, it does its work in silence. It threads through the empty space's invisible, yet omnipresent binding motion to meaning. Every sunrise, every orbit, every heartbeat owes its rhythm to that unseen geometry. Perhaps this is why gravity feels spiritual to some, a reminder that the universe is not a collection of things, but a relationship of curves, every mass tugging gently on every other. It is connection, made physical unity, expressed as motion. If love had a formula, it might look suspiciously like gravity's each entity bending the space around it, influencing others without touch, quietly ensuring that nothing drifts too far from everything else. Imagine the cosmic fabric as a vast ocean, and gravity as the slow tide that keeps all things afloat in harmony. Drop a star into that sea and ripples spread, curving nearby trajectories. Drop a galaxy and the ripples merge into waves that carry the universe forward in its graceful expansion. The pattern repeats from droplet to cluster, from human step to cosmic orbit, geometry shaping motion, reaffirming geometry. Even the expansion of the universe obeys this conversation. Dark energy may accelerate it, but gravity gives it rhythm, preventing it from flying apart too fast. It moderates, balances, and binds. So when you feel the pull of the Earth beneath you, consider that you are not being dragged down. You're following the simplest path through curved space-time, tracing a geometry older than light. Every falling leaf, every orbiting moon, every flickering photon follows that same invisible contour. In a universe full of sound and fury, gravity remains the still voice that never stops speaking. It says only one thing: in infinite variation, stay connected. For all its silence, gravity is the language of unity, the unseen hand that shapes, steadies, and reminds every particle where home is. Every shape in the universe obeys a quiet law: do the most with the least. Mathematicians call it the law of least energy, or more formally, the isoperimetric principle, the rule that among all possible shapes with the same boundary length, the sphere encloses the greatest volume with the least surface area. It is nature's favorite equation because it wastes nothing. A soap bubble is its most delicate expression. Dip a ring into soapy water, lift it into sunlight, and you'll see the law made visible: a trembling sphere, thin as thought, enclosing air with perfect efficiency. Surface tension pulls evenly in all directions, minimizing energy until balance is achieved. Any distortion, a bulge, a corner, a ripple requires extra force to maintain, so the bubble smooths itself out, rounding into rest. The same mathematics scales upward until it governs entire worlds. Planets, stars, droplets, even galaxies all owe their roundness to this simple optimization. When gravity is strong enough to overcome the rigidity of rock or the turbulence of gas, it pulls matter inward until internal pressure and gravity reach equilibrium, forming a sphere, the lowest energy shape in 3 dimensions. From the smallest bubble to the largest sun, the same geometry whispers: be efficient, be balanced, be round. Engineers know this instinctively, though they translate it into steel and mathematics. Pressure tanks are built cylindrical or spherical to distribute stress evenly. A square tank would burst at the corners where forces concentrate. A sphere has no weak point, no preferred direction. That same reasoning shapes submarines, their hulls curved to resist the crushing weight of deep oceans. It's why aircraft cabins and spacecraft modules are domed, curved surfaces, minimize stress differentials, reducing the chance of failure. Every rounded hull or dome on Earth is an homage to the same law that shapes planets. Biology learned this lesson long before humans did. Cells, the basic units of life, tend toward the sphere when unconstrained. The surface membrane of a cell acts much like a bubble elastic, responsive, self-healing. A spherical cell can hold the most cytoplasm for the least membrane area, conserving resources while maximizing internal volume. Even red blood cells, though flattened for flexibility, preserve curvature to optimize surface exchange. Viruses adopt spherical capsids to contain their genetic material efficiently, while seeds and spores curl themselves round to endure the friction of wind and water. Life's architecture, from microbes to mammals, repeats the same geometry: minimize effort, maximize endurance. In physics, this tendency is expressed through energy minimization. Systems evolve toward configurations of least potential energy, where forces are balanced and no further motion is required. The sphere is that equilibrium made visible, the geometric shorthand for rest. From the perspective of the cosmos, this is not just an aesthetic preference, it's a fundamental strategy. Energy is precious, and over cosmic time, inefficiency disappears. Jagged shapes radiate heat. Faster, sharp gradients invite collapse. Symmetry cost energy to sustain. So the universe refines itself, smoothing the sharp, erasing the unnecessary, until only efficiency remains. You can feel it in everything that endures. A pebble rounded by a river, a droplet forming mid-air, a planet circling its star. All are following the same least energy path: gravity, pressure, and surface tension, negotiating until nothing more can be saved or spent. The mathematician's version of this truth, the isoperimetric inequality, reads like poetry disguised as algebra for any closed surface. The ratio of its surface area to enclosed volume is always greater than or equal to that of a sphere. Equality occurs only when the shape is perfectly round. It is the universe's way of saying balance is a privilege earned through patience. When engineers design domes, when cells divide, when raindrops form and merge, each is reciting the same principle in a different dialect. And when we as observers feel a strange calm in the sight of a sphere, a pearl, a planet, a pupil, it may be because something in us recognizes that shape as home, the place where stress is lowest, equilibrium complete. The cube, the pyramid, the plane, they are inventions of will. The sphere is an act of surrender. It is what happens when energy stops struggling and begins to rest. In the end, the universe is not striving for perfection. It is simply saving effort, curving inward, until even motion finds stillness, and form becomes the gentlest version of itself. On a winter morning, somewhere between the city's first yawn and the sun's reluctant rise, a pigeon fluffs itself into a perfect ball of feathers. It looks almost comical, an urban planet with wings. But beneath that roundness lies physics at work, the thermodynamics of survival. Every living thing that fights the cold learns this same quiet rule. Roundness saves energy. It's the oldest trick in nature's playbook. When the temperature drops, warmth leaks away through surface area. The larger your surface compared to your volume, the faster you lose heat. That's why a thin metal spoon chills instantly while a loaf of bread stays warm inside for hours. And so when a pigeon puffs up, it's performing a precise act of geometry, minimizing surface, maximizing volume, conserving energy with feathery math. Its feathers trap tiny pockets of air, nature's lightest insulator. Each pocket slows the escape of heat, creating a thin, invisible atmosphere hugging its body. If you could see temperature as color, the pigeon would glow like a small star wrapped in a halo of orange warmth, quietly outsmarting the morning frost. The same rule governs penguins on the edge of the world. In the Antarctic cold, they huddle together in vast circles, thousands of black and white spheres merging into one slow-moving mass. Each penguin on the rim shivers in the wind until, by a kind of unspoken democracy, they rotate inward, letting a warmer neighbor take the chill. It looks like instinct, but it's thermodynamics in motion, a living model of heat exchange, an organism made of many bodies learning to act as one. Engineers studying these huddles have measured the temperature gradient within them, the outer layer near freezing the center, a balmy 35 degrees C. A difference sustained not by technology but by symmetry, a geometric trick borrowed from the cosmos itself. Even planets do the same thing. Earth, Jupiter, Venus all wear their own version of puffed feathers atmospheres. Each acts as a thermal blanket trapping heat that would otherwise escape into space. Earth's greenhouse gases keep its surface roughly 33 degrees warmer than it would be bare and airless. Venus went too far, the densest feather coat in the solar system, turning its surface into a furnace at 460 degrees. Mars went the other way, losing its warmth to the void, its thin air unable to hug the planet close. Every world is a pigeon or a penguin adjusting its shape and cover to balance heat and loss. From the street lamp's perch to the frozen pole to the orbits of planets, the same principle hums through creation: minimize exposure, maximize retention. The sphere is not just the most efficient shape for holding matter, it's also the best for holding warmth. The less surface a body presents, the less energy it loses. It's thermodynamics expressed as tenderness. There's a soft humor in realizing the universe is full of creatures feathered, rocky or gaseous, all trying to do the same thing: stay warm, stay round, stay alive. A pigeon puffing in a city square is following the same law that governs the glow of the sun. A penguin huddle is a blueprint for planetary climate control. Even your morning mug of coffee obeys the same geometry, its spherical bubbles conserving heat better than any sharp-edged container could. When we speak of energy conservation, we often mean electricity or fuel, but in truth it begins in every shape that nature makes. From cells to stars, the universe hides its wisdom. In comfort, roundness is the signature of something that has learned to keep itself alive. So the next time you see a puffed pigeon looking smug on a frosty branch, smile back. It's not lazy, it's efficient. It's a tiny physicist wrapped in feathers obeying the same equations that keep Earth's oceans liquid and Saturn's storms spinning. And in that quiet puff of warmth, you can glimpse the great unbroken pattern from bird to planet to star, the geometry of staying warm in a cold universe. Everywhere life endures, it does so by rounding itself toward peace. Cells, planets, hearts and suns all learn the same lesson, whispered by physics: when energy flows evenly, when nothing is wasted, when stress dissolves into symmetry, survival begins. A cell folds into roundness not for beauty but for balance. Its membrane curves inward until every molecule is equally content every surface at rest. A planet forms the same way, gathering its scattered fragments into one smooth curve so gravity can cradle it without strain. Even a human breath follows this pattern. Inhale, expands. Exhale, releases the rhythmic rounding of energy in motion. In that sense, roundness is not merely a shape. It's a strategy, the universe's way of protecting what it loves. When systems reach symmetry, they stop fighting themselves. Temperature evens out, pressure stabilizes orbits. Synchronize hearts, find rhythm. Equilibrium is not stasis. It is motion made gentle. You can see it in the way galaxies spin, hurricanes curl, or dancers turn motion, distributed so evenly that chaos can't find a foothold. Cultures have felt this truth long before they could measure it. In architecture, domes rose as earthly imitations of the heavens, from the Pantheon's oculus in Rome to the stupas of India and the mosques of Samarkand, every builder reaching for that quiet perfection where structure supports itself. In art, the circle became a symbol of continuity, the Zen Enso drawn in a single breath to represent balance without beginning or end. In meditation, the body instinctively curls into stillness, legs crossed, hands cupped, spine curved, a human geometry mirroring the stability of a planet at rest. Roundness is the posture of calm across both matter and spirit. From physics to philosophy, the same principle keeps resurfacing. Symmetry is self-care. The universe tends toward forms that conserve, not deplete. When energy pools unevenly, nature smooths it out. When systems break apart, gravity gathers them again. Even destruction, supernovae, volcanic eruptions, crashing waves is only imbalance correcting itself, clearing the way for roundness to return. Our ancestors intuited this in their rituals. They built stone circles, traced mandalas, danced in spirals, expressions of a pattern deeper than culture, older than language. To them, the circle wasn't geometry, it was forgiveness, a way of bringing all things back to center. Modern science, for all its instruments, still finds the same story in its data, from the smallest droplet to the largest galaxy. The equation of endurance is symmetry, so when you look at a raindrop clinging to a leaf or a planet glowing in the night, see them as acts of compassion, the universe tending to itself, tucking its sharp edges under warmth. Roundness is how energy rests without dying, how matter remembers to breathe. It is the shape of balance, the sound of silence made visible. We survive when we mirror that same patience, when we let our thoughts settle into circles, our habits into harmony, our lives into orbit around what truly sustains us. Symmetry, after all, is not perfection. It is kindness made physical. It's the cosmos taking care of its own tension, one curve at a time. And perhaps in the end, that is what roundness really means, not order imposed, but conflict resolved. Not beauty constructed, but peace achieved. Roundness as survival. Symmetry as the universe remembering to care for itself. Everything moves. From the drift of galaxies to the pulse of your wrist, nothing in the universe ever truly stops. And yet within all that motion there is a deeper rhythm, a stillness that endures beneath the spin. Physicists call it equilibrium. Poets might call it grace. It is the moment when every force finds its opposite, when motion no longer struggles, only flows. Planets orbit, atoms vibrate, stars swirl, and yet all obey the same invisible agreement: keep moving but never fall apart. That agreement is the stillness inside motion. If you could step outside time and watch the universe from afar, you would not see chaos at all. You would see waves balancing orbits, tracing harmony, energies converging into calm. Even the light that crosses billions of years travels not in haste, but in obedience, following the most effortless path through curved space. Every photon is a pilgrim of patience. Consider your own heartbeat. It contracts and releases again and again, not in defiance of stillness, but in partnership with it. The rhythm that sustains you is an echo of cosmic balance, expansion, compression, expansion again. The same pattern governs everything: the tides rise and fall, the seasons drift, the breathing of stars in their fusion and collapse. What we call time is just the choreography of that breathing. There is something humbling in realizing that rest is not the absence of motion, it is motion mastered. A spinning top appears still when it finds balance. A galaxy seems frozen in the sky only because every star inside it moves in perfect compromise. Even the Earth's calm horizon hides 1,000 invisible dances, tectonic plates, shifting magma, stirring clouds, forming atoms vibrating. Stillness is never silence, it is a symphony in tune. The more we learn about the cosmos, the more it teaches the same lesson: patience is power. Gravity doesn't rush to sculpt a planet. It takes billions of years to smooth chaos into a curve. Light doesn't fight its way through space. It follows the geometry of least resistance. Even entropy, that slow equalizer of everything, works by waiting, turning sharpness to softness, imbalance to ease. The universe doesn't conquer motion. It listens to it until balance answers back. That is perhaps why peace feels round in the human heart. When anger flares, when fear spikes, when thought spins out of orbit, something in us longs for gravity, for the steady pull back to center. We seek stillness not to escape motion, but to remember its purpose, to find the point where all directions cancel into calm. As you watch the night sky, every star is racing, every galaxy spinning, yet the heavens appear tranquil. That illusion is the truth of everything. The more immense the motion, the deeper the stillness it creates. The universe itself may be expanding at light speed, but from where we stand it feels serene, a reminder that peace is not lack of movement, but harmony within it. In the end, motion and stillness are not opposites. They are companions. One reveals the other as sound reveals silence. And to understand this, to see it in the roundness of a droplet in the orbit of a moon, in the quiet arc of your own breath, is to touch the oldest wisdom the universe knows. So before the final stillness comes, pause here in the turning. Feel the motion that holds you not as chaos but as care. Everything spins and yet nothing is lost. Even movement itself seeks rest. Even time patient as gravity curves gently toward peace. There comes a moment at the edge of every motion when the universe exhales. The droplets stop trembling, the planets complete their orbits, the galaxies drift into quiet balance, and what remains is stillness, vast and tender, as if creation itself had finally grown calm enough to listen. Everything that has ever existed has followed the same journey, from jagged to smooth, from struggle to symmetry, from noise to rest. A raindrop rounding itself in free fall, a planet softening under gravity's patience, a galaxy unwinding into a spiral of light. Even the universe, still expanding, is slowly learning the art of balance, each force, each curve, each breath of energy seeking not to conquer, but to rest in harmony. The smallest bubble and the largest cluster of galaxies share one law: to do the most with the least, to find shape through surrender, to curve inward until effort disappears. And if we listen closely, we can hear that law in ourselves, the slow rounding of emotion, the steady pull toward calm. Every heartbeat, every thought, every act of kindness is the same geometry translated into life. The science for sleep rhythm returns now, as if to tuck us into the same pattern it has been describing all along. In the beginning, there was motion dust swirling light, scattering stars, igniting. Then came gravity drawing matter into meaning. Then spin sculpting chaos into curves. Then time the patient editor smoothing every edge. And finally the quiet, the roundness that remains when energy has learned to rest. If you were to drift beyond the Milky Way and look back, you would see not chaos but order. Not noise, but music spirals within spirals, all turning in silence. From a single droplet trembling on a leaf to the slow heartbeat of a galaxy, everything is part of the same pulse, the rhythm of return. Even light obeys it, even thought, even you. Stillness, we realize, is not the end of motion. It is its fulfillment. The state reached when every force has found its balance, when every orbit has remembered its center, when every question softens into awe. And so the universe continues round, breathing awake a slow spiral of becoming that never fully stops, because to be alive is to move, and to move well is to move toward peace. In that peace we find humility, in that humility wonder, the droplet, the planet, the galaxy, the universe, each curving toward the same invisible point of rest, each whispering the same ancient truth. Stillness is the shape of understanding. Roundness is the memory of love. And as the final image fades, the cosmos drifting into soft equilibrium, its edges gone, its breath slow, we are left with only the quiet and a single thought carried gently across all scales of existence. Perhaps mystery is how the universe keeps us awake to wonder. Thank you so much for keeping me company tonight. Don't forget to subscribe so we can share many more stories together.